Hello. Am I audible?
Yes, ma'am. Good evening.
Good evening, all. Yes. So today we are going to solve the mock problems. I hope all of you have already done it. So I can see some 43 people here. So can you just raise your hand? How many of you have tried mock? Okay, so around 14, 15 people. All right. So we'll start from the first problem here. Okay. So before we start the session, I just wanted to know if there was any specific doubt that we can take later.
Hello.
Yes, please.
Yes, ma'am, I had a small doubt in last week's graded assignment regarding normal distribution.
Okay, you have doubt from the
Okay.
graded assignment of week 4.
Yeah.
Okay, so these things I will take off once the mock is done. So,
Yeah, sure, ma'am.
Okay.
And
Yeah.
yes, I have doubt related to a couple of topics, and related to that, questions are asked in this mock test one also. Ma'am, when two random variables are given, right? Hello. Hello. Ma'am, am I audible?
Yes, you are audible.
Sorry, I got disconnected in between. I will share it again.
Yes, ma'am. Now, can I say, ma'am?
Yeah, please.
Yes, ma'am. I was saying that related to a couple of topics related to that, questions are asked in this mock test also, like question number 18 and question number 10, like when other random variables are given and one belongs to, say, for example, uniform, and the other one belongs to geometry, a function is defined using them. So what will be the
Okay, it
resultant?
is from the mock.
Correct. So what will be the
Okay,
resultant function?
yeah, mock problems we'll see here.
Yes,
Okay.
yes. So, and
Mock problems we are going to see
and
them.
those topics only, ma'am, related to those topics only.
All right.
Okay.
Anything else?
No, ma'am. Thank you.
Okay, thank you. Okay. So we'll start from our first problem. Question number 1 says that the joint probability mass function of two discrete random variables. We have two random variables here, that is x and y, both are discrete, and their joint probability mass function is given in this table, right? Now, the first thing that you have to check is whether x and y are independent. So how do we check the independence of two random variables? let's say we have the joint PMF given to us. So how do we check the PMF independence?
Product of their marginal probability
Product
equal
of
to
marginal
intersection.
PMF.
It's a product of
Yes, right.
marginal.
So if I ask you, what is the marginal of, what is probability x equal 1?
1 by 2.
2. 1 by 2.
1 by 2.
So you have to sum 1 by 4 plus 1 by 4, right? So it becomes 1 by 2. Then what is probability x equal to?
1 by 2.
1 by 2.
1 by
Again, 1 by
2.
2. That is 3 by 8 plus 1 by
1
8.
by 8.
So it is 1 by 2. Now you have to find probability y equals 1.
5 by 8.
So probability y equals 1 become 5 by
8.
8. Right. And probability y equals 2
3 by 8.
becomes 3 by 8. Right. So the marginals we have seen. Now, how do we check the independence? We have to check whether the product of marginals is equal to the joint. So can you tell me whether it is independent or not?
No, ma'am.
Not independent.
Independent.
Okay. Independent or not independent?
Not
Not
independent.
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 Not
So-
independent.
So okay. So what is the reason it is not independent? Can you give one example?
Because fxy 1, 1
Okay.
is equal to means it will not satisfy.
So
Fx of
probability x equal 1,
not-
comma y equal 1 is not equal to
probability of
probability x equal 1 into
and,
probability y equal 1,
y equal 1. Yeah.
right? So it is very straightforward. So whenever you have to check whether the two random variables are independent or not, you just have to check whether the product of marginal is equal to joint or not for all the pair of values that x and y takes, correct? So in this case, we have found a counter example, and it says probability of x equal 1 and y equals 1 is not equal to probability x equal 1 times probability y equals 1. So the random variables x and y are not independent here. Okay.
And left side, P of x1, y1 is equal to 1 by 4, right? 1 by 4. And
Okay. Tell me again.
P of x is equal to 1, y is equal to 1. That value is 1 by 4. And that
Okay.
is not equal to 5 by 8 multiplied by
Multiplied by
1 by 2
1 by
multiplied
2.
1 by 2, right? So this is not equal. So
it is not independent.
it is not independent. So whenever you have to check for independence, just check for this condition. I mean, equal to sign here. Okay. So you have to check this for all the values, not just for one value. So if you find one counter example for which it is not satisfied, it means they are not independent. Otherwise, if for every pair of values, this equality comes, this equality holds, then we say it is independent. Now let's move to our next problem. There you have to find the value for probability that x plus y equals to 3.
5 by 8, ma'am.
5 by 8.
5 by 8. Okay. Why it is 5 by 8? Can somebody explain?
If we take 1, 2 and 2, 1.
Two conditional.
1, 2 and 2, 1.
Yeah.
Okay.
For
Yes.
satisfaction of x plus y is equal to 3, there
1, 2 is 3 by 8 and 2, 1 is 1 by 4.
1, 2 is 1 by 4 and 2, 1 is 3 by 8.
No, ma'am. 1 by
No, ma'am.
1 by 4, ma'am.
Opposite, ma'am. 1, 2 is
Opposite,
3 by
ma'am.
8 and
Correct.
2, 1 is 1 by 4 actually.
Sorry, yeah.
And if we add both, then we will get the answer.
Okay. So how did you find this? You saw that there like x is taking just two values and y is taking just two values. So if we write this table, in this form. So you have an x, you have y. This is for question number 2. And you have x plus y, right? And fxy is given to us. So x is taking the value 1, y is taking the value 1, x is taking value 1 with y is taking value 2, x2, y1 and x2, y2. Their corresponding probabilities are also given to us. So for x equal 1, y equals 1, we have 1 by 4. For x equal 1, y equals 2, we have 1 by 4. For x equal 2, y equal 1, we have 3 by 8. And this is 1 by 8. Now, what all values your x plus y can take? So what is the range of x plus y?
2, 3, and 4.
3, 4.
2, 3, and 4. Okay, let's see this. So if you add 1 plus 1, it's 2, 3, it's 3, and 4. So you can see that x plus y is taking the value 2, 3, and 4. So what is the probability of x plus y taking the value 2?
1 by 4.
1 by 4.
1 by 4. What is the probability? Why is it 1 by 4? Because we see that there's just one case, like 1, 1, for which your x plus y is 2, and the probability is given as 1 by 4. Now, for a range of xy to be 3, so what is the probability that your x plus y is taking the value 3?
5 by 8.
5 by 8.
5 by 8, because we have two such cases where one case is where x is taking the value 1 with y is taking the value 2, and x is taking the value 2 with y taking the value 1. So we have here two possibilities, and the corresponding probabilities will have to add. So it becomes 5 by 8. You'll have to add these two. Now again for 4, probability that x plus y taking the value 4. So it becomes 1 by 8, because we have just one possibility here. So this is 1 by 8. Here we had to find what is the value of probability that x plus y equal to 3. So from there, we can clearly see that it's taking the value 3 with probability 5 by 8. Okay. Any doubt so far?
So this is probably not a doubt. I just wanted to add from my side that this is like a common method that you can use for any function. So I think this table method, I think I probably call it table method in the lecture. I don't know, but it's a good method to just get a handle on. It's a comment from my side.
Yeah. So thank you, sir. Okay. So the third problem that we have here is, what is the probability that maximum of x comma y is less than equal to 2?
1.
Ma'am, it will be 1.
1.
It is going to be
1.
Yes,
1,
we'll consider
right?
all the combinations actually. Yeah.
Yeah. So again, in the table, we can just make another column that will be for x plus y, max of x comma y. So in the first case, it is 1. The second one, it is 2, again 2 and 2. So we had to find here that probability max of xy is less than equal to 2. So either maximum of xy can be 1 or it can be 2. We have just two possibilities, either 1 or 2. So probability that max of xy less than equal to 2. So this is going to be probability that max of xy is equal to 1 plus probability that max of xy equal to 2. So it's the whole probabilities that it's covering. So it will come out to be 1. Okay. So is this clear? The first problem is clear to everyone?
Yes, ma'am.
Yes, ma'am.
Your voice is not clear.
Ma'am, can you explain third part again? I know.
The third part again. Okay. See, we had to find probability that max of xy is equal to 2. Right? So from the table, let's see, you have two random variables, right? X and Y. Now we have made one column here that is for max of xy. So given x equal 1, y equal 1, maximum of xy is going to be 1. Given x equal 1, y equal to 2, maximum is going to be 2. Similarly, for the third and the fourth case, it is the maximum is going to be 2. Correct?
Yes.
So if we have to find the probability that maximum of xy is less than equal to 2, so what we can do in this case? We know that maximum is taking the value 1 and 2, right?
Yes, ma'am. Yes.
Right. So to find this probability, either maximum is equal to 1 or it is equal to 2.
Yes, ma'am.
Now, if you add both the probabilities, what will you get? What is the probability that max of xy equal to 1? Can you look at this table and figure out?
1 by 4.
Okay, this is 1 by 4. And what is the probability that max of xy equal to 2?
It is 1 by 8.
It is 1 by 8. Why is
Yes.
it 1 by 8?
3 by 4
What?
altogether.
Yeah,
1 by 4, 3 by 8, 1 by 8.
You have you have all these three cases for which your maximum
Oh.
is taking the value 2,
Oh,
right?
okay, ma'am. Okay, ma'am.
So you will
Yes,
have you got it?
I got it, ma'am. Yes, ma'am.
Okay. Okay.
Thank you, ma'am.
Yeah. So we'll move to the next problem now. Okay. Question number 2. We have suppose x is normally distributed with mean 0 and variance 1. Okay. So you have a random variable that is normally distributed, and the mean is given to be 0 and variance is given to be 1. We have also given that probability x less than equal to 2 equal to 0.1. Now, what is the probability that your x lies between -2 to 2? This is what you have to find. So, can you, there's a name for this distribution. It is a standard normal random variable, right? Because it has a mean of 0 and variance as 1.
Yes,
now, in case of normal distribution, we know that your distribution is symmetric about the mean. Correct? So in this case, the mean is 0 and the area that it covers on both the side, on the left hand side and the right hand side, is are equal. Correct? Now it is given to us, this information is given to us, that is probability x less than -2. This area, this probability is 0.1. So how will you find that the probability x lies between -2 to 2?
In
this case,
it's a symmetric graph, ma'am.
Yes.
So the area, on the left hand side less than -2 is 0.1. So similarly,
Yes.
on the right hand side greater than
Yeah.
equal to 2 will be 0.1, right?
0.1.
Correct.
Yes.
So
Yeah.
I got 0.1 plus 0.1, 0.2. So total area is
1
1.
minus
1 minus
0.2.
0.2 is 0.1.
Yeah.
Yes.
Yes.
So
Ma'am, whole
Yeah,
area
that-
is 1.
yeah, the whole area should be 1, right?
Area under the curve is 1 probability.
So we knew that your distribution is going to be symmetric towards the mean, and the mean here is normal 0, 1. And the information that is given to us that probability x less than -2 is 0.1. Since this is symmetric, so similarly probability that x greater than 2 will also be same. So this will also be equal to 0.1. And since the total area that it covers should be equal to 1, the area that is here in the orange shaded region, that should be 1 minus
0.2.
0.2. So it becomes 0.8.
Okay, I have one additional question to ask based on this question. Supposing the variance is not given, right? What will your answer be? Everything else is the same in the problem, but the variance is not given.
Sir, if mean is given as 0, sir, then I will consider variance standard deviation as 1 only.
Why? Variance can be anything. No, you can have a normal distribution with mean 0 and variance 20, 30, 0.1, 0.01. Variance can be anything.
Even then, the distribution
So the
will be
answer
symmetric
will
about
still remain the same because we have probability of x less than -2 is already defined as 0.1. And since it is symmetric around the mean.
Absolutely, yeah. So in fact, can you find the variance? Do you think you can find the variance?
For standard distribution, it is all 0 to 1 only, sir.
See, the standard, if x is standard normal, yes, you're right, mean will be 0, variance is 1, that's correct. But supposing I don't give the variance, but I only give probability that x is less than -2 is 0.1. Do you think that's sufficient to find the variance?
I think we have to integrate the normal distribution equation from 0 to 0 to -2, since we know that cumulative CDF of that region.
Yeah, okay, yeah. Think about that. That's one interesting question. The other question I had is, supposing I don't give the mean. Okay, I say x is normally distributed, mean is not given, variance is not given, and the rest of the problem is the same. Is it? Can you conclude anything?
No, sir. So I don't know about if you don't give mean or variance, but I think if you give mean, then around the mean the probability should be 0.5, no? Like there is some, I mean, I think I've heard something in the lecture or read somewhere.
Yeah, around the mean being to the left of the mean, it's 0.5, right of the mean,
Right of the mean is
0.5. True.
So isn't all the normal distribution curves are symmetrically distributed between the mean?
About the mean, yeah, around the mean it is symmetric, yes. So supposing I don't give the mean, I think there is no chance, right? But
Yes,
I should
sir,
say the
because-
mean. But supposing I say the mean is 1 instead of 0.
Yeah, then we won't be able to.
Then we have to consider in between like x minus mu kind of thing. Basically, the distribution between 1 and 2 will be same as 0 and 1.
Okay.
I think, for example, here if you ask between, for example, if the mean is 1 and if you ask in between 0 and 2, in that case, I think we can still find out because it will be equally distributed.
Okay. Anyway, think about these questions. I think the CDF of the normal will be needed if the mean is not 0. And you'll have to express the answer in terms of that. Okay.
Sir, can we standardize the?
I'm sorry.
Can we standardize this if mean is not 0? Then
it's a little bit more complicated. It is doable. I think maybe one of you can respond on the discourse forum with what the answer would be. Okay. I'll just, I mean, it's slightly advanced. Don't worry about it for the quiz. But think about it if you have time. Okay.
Sir, I was thinking what we are doing there, z is equal to x minus mu upon standard deviation. Can we do that way? This if suppose mean is not 0.
But sir said there is no mu given.
Yeah. So if they give some mu and deviation, then I think we can go with the method you told. But if nothing is given, just that.
Okay.
Yeah, I mean, you can do it. It's doable because this probability actually, given the mean, it determines the sigma. That's correct. But you will have to use the CDF of the standard normal. That's all. The answer will be in terms of that FZ or something. Okay.
But sir, here, sir, like if the mean is given only 1 and like say if the variance is not given, it will be really difficult because we do not know how much sigma is getting shifted towards right and towards left. Although the standard normal distribution is equally distributed from the mean, and we have given only the mean, as you said that it is 1. But unless we get the value of variance, like how much it is shifted toward sigma value towards right and left, it's really difficult to find out what is the value of that x lies between -2 and 2.
Okay, you can think about that problem that sir had just asked. And you can also write it on Discourse, okay? Yeah.
I hope I mean, I had to sort of, something happened here for a little while. I couldn't figure it out. I was just making the point that given the mean and one of these probabilities, you can determine the sigma in terms of the FZ, which is like the CDF of the standard normal, right? Somebody was mentioning that, you can find out
Yes,
these
sir.
areas
Yeah.
using that.
Yeah.
And then in terms of that FZ or FZ inverse, you can express any other probability. That's all. That's the point. I think it's okay. I think if you sort of understood that, that's good enough. Okay.
Thank you, sir.
Right.
It's important because later on, this kind of calculation is bread and butter in statistics. So it's good to get a good handle on that.
You are there for a second.
Yes.
Yes, Nikita, please
Okay,
carry
yeah.
on.
Yeah. Thank you, sir. Okay, so the third problem that we have here is you have two unbiased tie that are thrown repeatedly. Okay, now you have to find what is the expected number of trials that you have that is needed to get the same value on both the dice. So you have two dice. Yeah, anybody was speaking?
Ma'am,
Just in the previous
question 2, ma'am.
Okay, you have doubt in question 2.
Question 2, I just wanted.
Okay.
Yeah. Ma'am, in this question, what will be the function?
What
It
will
will
be
be only x function. Like
Okay.
it is just given that x is like arbitrary, and sir told that we have to give integration and then upper limit, and we have to find the CDF. So what will be in the function? How can we determine the function if it is not given?
Okay, so you have your random variable x, right? You know x is normally distributed, right? X is normally distributed with some mean and some variance. Let's say we don't know what is the mean, what
Yes.
is the variance, but still we can convert it to the standard normal form, isn't it? So how do we do it? How do we convert?
Only for normal form we can take it as x. No. See,
Yeah, how do you
if we
convert?
want to integrate, there has to be a function, right? For
No.
x, just we have
Okay.
this variance called.
No, I think the question he's asking is way too basic,
It is,
Nikita. See, the
Okay.
see, thing is, when she says normal distribution, the PDF is already implied, right? This definition is in terms of the PDF. If you say x is
Yeah.
normal with mean mu and variance sigma square, there is a PDF. Right? There is a probability density function, some 1 by root 2 pi sigma e power minus x minus mu whole square by 2 sigma square. So that formula you should already know, as in there'll be in fact, even in the quiz we'll give you a table, you can look it up, but otherwise you can also look in the lecture. The PDF for the normal is an accepted form, as in it's a fixed formula, and that formula is already there. And no point in integrating those things. I mean, nobody can integrate such functions and easily do anything. So what people normally employ for that is they use the standard normal, they convert any normal distribution to that, and then they assume some capital FZ. I don't know, Nikita, is this introduced in week 4 or maybe later?
So this is introduced in week 4.
Is it introduced in week 4, right? So
Yeah,
what you do is you introduce some function capital FZ, and Z is this zero mean unit variance normal distribution CDF. So you assume that this FZ is known, okay, and express all your answers in terms of FZ. You know, when you do trigonometry problems, you always express the answer in terms of sine theta, cos theta, right? But what is sine theta? You don't know what sine theta is. You have to rely on some computation to find out sine theta, right? Like that, you can assume this fz is also some known function. Somebody will give you the value. If you say fz of 0.1, somebody will tell you what it is.
So it is a computer-based value, right?
Yeah,
Which
yeah,
is
yeah,
given.
yeah. Many computing packages will give you the number. It's just a known function. And so any probability, like probability of -2 less than x less than 2 when x is normal, can be expressed in terms of this fz. Okay, so it's a very important fact. I'm sure I emphasize it in the lectures a lot. So
Yes, sir.
you
Yes,
have
sir.
to know how to write it in terms of fz.
X minus
that's
mu
all.
by
And
sigma.
just
Yes.
like fz is known, fz inverse is also known. Okay.
Sure. Okay,
so
sir.
both
Thank
of
you.
these are known. So once you know those, you can express anything in terms of it.
Okay.
Okay. Thank you, sir.
Thank you, sir.
Okay, so we were at the third problem.
Yeah, it's the third problem is a big jump to discrete. Okay, so forget
Yeah.
about all CDF, PDF integration and all. No integration is needed for problem 3.
So here
Yes.
you have two unbiased die, and you are rolling these 2 dice. Now what you have to find there is like what is the expected number of trials that will be needed so that you get the same value on both the dice, right? So when you throw 2 dice together, so how many outcomes do we get?
36.
36. And okay, so before we go to the solution part, I just wanted to know, can you figure out what kind of distribution?
Geometric, ma'am. It's a geometric distribution.
Geometric distribution.
It's a geometric distribution. So yeah, can
Geometric
somebody
1 by 6.
1 by 6.
Geometric 1 by 6. Okay, so can you tell me why is it geometric 1 by 6?
And because we are finding the number of trials to get the same value. Until we don't get the same value on both dice, which we can't really tell the trials. Means the first trial needed to get the same value on both the dice.
Yes.
That is our success. That is our
Access,
success.
Yeah,
success.
Yeah, so geometric random variable models.
Out
Yeah.
of 36 events, there are 6 events where both the dice.
Yeah, that is right, right.
Correct.
Yeah.
It's a 6 by 36.
Correct. So geometric random variable models the number of trials needed to get the first success. So what is the success defined here? It is defined as the value you get on the same value that you get on both the dice. So
Right.
out of those 36 outcomes, we know that there are 6 outcomes where you get the same values on both the dice, right?
Yes.
And so if you continuously throw 2 dice together, 2 of the die together, so either you get the same value on the first trial, or you get the same value on the second trial, or you get the same value on the third trial or fourth trial, it will go on, right? So such kind of situation models your geometric distribution, and we know that the probability of success for each of the trial is going to be same. So you throw one pair of die, you will get 1 by 36, 6 upon 36, that is 1 upon 6 as the probability. So that will be same in all the cases for all the trials that you're performing, right? So this models nothing but geometric p distribution. So P in this case is 1 upon 6. We also know that the expectation of geometric random variable is given by, so if you have a
1 by P.
yeah.
1 by P, ma'am.
1 upon P.
Yeah,
1
so
upon
you
P.
have a random variable x that has the parameter P, then the expectation of x is given as 1 by P. Since here P was 1 by 6, so the correct answer will be 6.
Ma'am, the expectation is week 5, is it?
Expectation is week 3.
Week 3.
Expectation is week 3. Yeah.
Ma'am, how did we get this one? Yes, 1 by 6 was clear to me. Like probability is 1 by 6.
Yeah.
And then okay, then we simply calculate the expected value.
Yes. So we knew that in case of geometric random variable, like if you had a geometric random variable, expectation of x is given as 1 by P. Yes. I'm sure it is there in week 0.
Yes, ma'am. Yes.
Ma'am, but
not expected value.
Not clear. Ma'am. That's 1 by
sorry.
6, not 1 by P.
1 by
proof
P.
is not clear for geometric. That proof is not clear, madam, in video also. Can
Okay.
we prove that?
Why
Okay.
expectation of x is 1 by p?
Yeah, ma'am, for geometry.
Okay. All right. So maybe at the end, I will just write it here. At the end, we can go through the proof. There is enough time. Okay. If there is not enough time, you can write it on discourse and
Yeah,
we'll
actually,
see the proof
there's
later.
lots of discourse posts on this topic, no, Nikita? I think from the previous years, are they accessible to people? I think.
Yeah, last 3 terms it is accessible, sir.
Yeah. So I think there were several questions on this, and people have given long posts describing why this expectation calculation comes out to 1 by p. So I think you can point to that also.
Yeah. So expectation of x.
Maybe somebody in this group can go find it on discourse and post it on the chat or something. There is a thread, I remember this from before.
Yeah, and also like what is the practical application? So many students had asked.
So if you want to sort of think a bit clearly about this problem, the way you have to say is, if you go to this question, it says expected number of trials. The question is very, it's very brief. Okay. So basically, first, you have to think of the number of trials as the random variable of interest. Okay. So this x that Nikita has been writing is actually the number of trials needed to get the same value on both the dice. Okay, so that is a random variable, and exactly like she has argued, that random variable will end up having a geometric distribution with a success probability of 1 by 6. You can conclude it in various ways. Of course, you can go back to the basics and say probability that x equals k will be 1 minus p power k minus 1 times p. Right, so it should not succeed for the first k minus 1, and in the kth one it should succeed. So x denotes the number of trials needed to get the same value on both the dice. That is a random variable. It has a geometric distribution with parameter 1 by 6. And then when we say expected number of trials, we are really asking for expected value of x. And from your formula for geometric distribution in the quiz also, the formula sheet will be there. You can go look at the geometric distribution. It will say what E of x is. And you just read out E of x as 6.
Sir, just a small doubt, sir. Say, for example, if the word expected is not there in the sentence, and it is only written that find the number of trials needed to get the first success, then what should be our approach, sir?
It will be a random variable. It's not a fixed number, no. You will get just a random variable x, which is geometric distributed. That's all. You can't give one number.
But
right.
And the I'm saying that the word expected is not there, and the
yeah, that's what I meant. If the expected is not there, the answer will not be a number. It will be a random variable. Right? If you say find the number of trials needed, it's actually a random variable. Every time you do it, you will get a different number. You can only talk about the probabilities of those numbers. So that's why you will get a random variable. Because we said expected number, we are talking about the average of that random variable. It's the expected value. And that ends up being a number 6.
The answer is 6, is it, sir?
I'm sorry?
The answer is 6, is it? For
yes, that's what she has said. No? Okay. 1 by p.
Yeah.
Okay. Yeah, so
yes.
The expected value of a random variable is a number. The random variable itself is some random variable, right? It takes different values with different probabilities. Think about that. It'll take a little bit of time to sink in, but that's how it is.
Okay, so any more doubt in question number 3?
Just if I want to emphasize that point again, suppose the word expected is not there, right? Find the number of trials needed. Every time you do the experiment, you will get a different number. No, you may be really lucky the first time itself. You may get sometime. Sometimes you may get it in the 20th attempt only. Sometimes you may get in the 15th attempt. Sometimes. So if you don't say expected, if you say number of trials, it's not a fixed number. You can it's a distribution. It's a random variable, right?
That
Because
was
we
my
said
doubt, sir.
yeah, because we said expected number. It's you first find the random variable, which is the number of trials, and take its expected value. For that, you will get the answer as one number, which is 6. Okay, so word expected is very crucial there.
Yes,
Seems
sir.
like a
Yes,
simple
sir.
number, but it's very crucial word.
I missed that part, sir. Actually, I got into that kind of understanding that I have to find out exactly the number of trials to get the first success. Sir.
That will not be a fixed number, no, it will be a random number.
Correct. Because the concept is clear and the formula is clear. Yes. Thank you, sir. Thank you, sir.
Okay, so let's move to the question number 4.
Hello, ma'am.
Yes.
If the here the expected it will not be there, and the number of trials needed to get the same value, then it will be a geometric distribution only, right, sir? Right, ma'am. It will be the only that geometric distribution will be there. If it is saying that find the number of trials needed to get the same value on both sides.
Yeah, this is what we just discussed here.
Yeah.
Okay.
So your number of trials will vary. It will not be same.
Basically, it will be that geometric distribution, no? That it will be that geometric distribution.
Yes,
Yeah,
it will
it
be
can
a
be
geometric
anything.
random
Yeah.
variable. Yeah, it will be a geometric random variable. The best you can say at that point is it will be a geometric random variable. That's all you can say.
Okay.
You can't say any fixed number as the answer.
Okay, so here we have a random variable x that is discrete, and the probability mass function is given to us, right? So probability that your x is taking the value k is 0.4. Probability that x is taking the value 2 is 0.15. It's taking the value 3 is 0.35, and probability that x taking the value 4 is 0.10. And from this PMF, we have to find the CDF of x. Right. So how do we find the CDF? So we know that it is a discrete random variable. We can plot the graph first, right? So for x equal 1, x equal 2, x equal 3, x equal 4. If we want to plot the CDF of x, so what kind of structure will it give? What kind of CDF
It's a
will it
step
give?
wise. A jump.
It should have the jump, right?
Yeah.
So
to the probability at that point.
yeah. So whenever we have to write the CDF, the one thing that we always do is like for x less than 1, it should be, the probability should be 0. So that we will fix here. So probability that x is less than 1 is 0. And for x greater than equal to 4, it should give the value 1. So probability that x is greater than 4 should be equal to 1. Now we have to look for the intervals x line between 1 to 2. What is the probability that it will give for x2 to 3 and for 3 to 4? The PMF is provided to us. So for x equal to 1, probability that it is giving is 0.4.
0.4. Yeah.
Right? So for x lying between 1 to 2, so this is our x and this is, we are trying to plot fx of x. Now for x lying between 1 to 2, so for x less than 1, it is going to give the value 0.
0.
Okay. For x lying between 1 to 2, so for x equal to 1, it is 0.4. So there is a direct jump here, and we have for x lying between 1 to 2, it gives the probability 0.4. Now for x lying between 2 to 3,
0.55.
0.55, we'll
Right.
have to add the previous probability, right?
Yes, it will have a jump of 0.415.
Yes. So this probability plus 0.15 probability, it will get added, and you will get
between 1 and 2, I think it's between 1 and 2, what would be the probability?
it is 0.4.
Between 1 and 2?
It is 0.4. So again, if you have to find for x lying between 3 to 4, so again you see for x equal to 3, you have a probability of 0.35, right? So you will have to add this 0.35 to this previous probability, right? So what is the sum total?
0.90.
So 0.90, right? So there you will get, say at 0.90, you are getting so this is for 0.0. Now for x lying x greater than equal to 4, x greater than equal to 4,
1.
you will have to add all the probabilities here. So it will be 1. We know that the CDF is a function from a real line to 0, 1, right? The closed interval 0, 1.
Yes.
And it should be an increasing function. We see from here that it is an increasing function, and as x tends to 0, the value, it should tend towards 0, and for as x tends towards 1, it should go towards 1.
Not x, Nikita.
Sorry,
x goes to minus infinity.
minus
it should
infinity,
go to 0,
yeah,
plus
yeah,
infinity.
right. Yes, sir. So as x tends to minus infinity, your fx will go to 0, and x tends to infinity, it will go to 1. So if you look at the options over here, so for x less than 0, x less than 1, it is 0. For x lies between 1 to 2, you have 0.4. So this is a correct answer here.
Second option B.
Yes.
Ma'am?
Yes.
I think someone was asking that what about a point in between 1 and 2. I think someone was asking that what is the probability in between 1 and 2, like say for example 1.5. So should we say 0 or 0.4 only?
See, first thing is, see, when you say between 1 and 2, what is the probability? What do you mean by that? Be a bit more precise. See, what the CDF says is, what is capital Fx of small x? It's the
CDF.
probability that capital X is less than or equal to small x.
Yes, sir.
So the CDF itself is a probability. So if you ask a question, what is the probability that the random variable is between 1 and 2? That answer is, you can compute it from the CDF, but it's not the CDF. CDF for every value of x simply says the probability that capital X is less than or equal to x. Okay, so be careful about that. So supposing, for instance, if x is 1.5, right, CDF at 1.5 is probability that capital X is less than or equal to 1.5. That's all. That's the way to understand.
Yes, sir.
Ma'am, here like x less than 1 value 0, how do we get from the question itself?
Okay, so from the definition, so fx of x, we know it is probability x less than equal to x. Now you are saying your x, if x is less than 1, right? So if you put it here, for any x naught that is less than 1, it should be 0, because your x is just taking the value discrete point 1, 2, 3, and 4. For any x that is less than, that is not these discrete values, it is giving the values 0 for x less than 1, right? Your x is starting from 1, 2, 3, and 4. These are the values that your x is taking. Now, if you take any x that is less than 1, so we don't have we can also write it here just for x equals 0, it is 0. For any other x, it is probability is 0, right? So if you take any x that is less than 1, it will give you the value 0 because we don't have any such x.
Ma'am, like in the previous question, like we understood, like from minus infinity to 0, it is like 0, and from plus, when we're approaching towards plus infinity, then
Minus,
we have the
can you
value of
repeat
1.
minus infinity to 0?
It from minus infinity to 0, we have the 0 values, and from 0 to when we're going towards plus infinity, then we have the maximum value of 1. So when we implement this, extrapolate this phenomenon there, so if I go a discrete value, maybe I can get -1 or -2 like that, because
no.
or
So
because sometimes it is mentioned in the question that okay, otherwise it is 0, but here when it is not mentioned, how do we assume like
so
okay,
here what it was said is like the first property that your CDF should follow is it should be an increasing function, and the second thing that was said is like as your
I
x
think his
will
question is more
approach,
about the distribution itself, Nikita. If you go up a little bit, see,
yeah,
he's asking about so probability is that x equal to k. You have defined it for four values. Okay.
Yes.
So what about for k not equal to these values? I think something like that is the question.
Okay, so yeah,
That's where you've said it has to be 0 because, all this adds up to 1.
To 1, right?
No other values taken by x. Is that the question, or did I misunderstand?
Yes, sir. Like in some question, it is mentioned some values.
Yeah. Here it is not mentioned, but if you add up all these probabilities, you get 1, no?
Yes, sir.
So there can be no other value for x with non-zero probability.
Okay, thank you, sir.
So x takes no other values, only 1, 2, 3, 4. So I think the cause for confusion in these kind of questions is there's too many x's floating around. There's capital X, there is small x.
Yes, sir.
Normally, it's a bit confusing, and then you're plotting this versus x. So if you don't like x, you can plot fx of t versus t. I mean, it doesn't matter. Instead of small x, you can use t. It's the same thing.
Any other variable?
Yeah, you can use any other variable, u or v or something, if that is better for you to understand. Okay.
So question number 5 here we have, this is again from a continuous distribution. The problem statement says the time taken by Krishna to complete a race follows an exponential distribution. Okay, so this information that is given to us, and the expectation is given to be 20 minutes. Now you have to, the first question here that is asked is, what is the probability that Krishna will take less than 15 minutes to complete the race, right? So what information is given to us that you have a random variable. So that is defined by the time taken by Krishna to complete a race. And it is modeled by exponential distribution, where the parameter itself is not given, but expected time is given to us. And we know that if your random variable x models the exponential distribution with some parameter lambda, then expected value of x is given by 1 upon lambda. So we can use this information to find our parameter lambda, because expectation of the random variable here is given to us, that is 20 minutes. So this lambda here was unknown to us, and we knew that expected value was 1 upon lambda. So the parameter here is going to be just 1 upon 20. So this is what we know here. let's move to the first question. The first question says, what is the probability that Krishna will take less than 15 minutes? So our random variable X was defined as time taken by Krishna to complete a race. And in the first problem, we have to find what is the probability that Krishna takes less than 15 minutes to complete the race. So, okay.
Excuse me, ma'am.
Yes.
Lambda should be 20 minutes.
Lambda
Hello?
should be 20. No. So your random variable is exponential lambda, right? And we know that if you have a random variable X that models the exponential distribution with parameter lambda, then its expected value is given by 1 upon lambda.
Okay.
Right? So since the expected value was 20, expected time was 20 minutes, right? So the parameter should be 1 upon 20.
Okay.
Okay. So this is our parameter here, 1 upon 20. So the first question is, what is the probability that X is less than 15? So how do we find this?
Integrate 0 to 15.
Oh, we can directly use the.
We can use the
Yeah,
We can use
we
the
can-
formula, ma'am, directly.
Yeah,
E
we
raised to
can-
minus lambda x.
1 minus e raised
1
to-
minus e to the power minus lambda x.
Yeah.
Yeah. So this is nothing but the CDF, right? So this is fx of 15, basically. And your X is exponential random variable. So if you have an exponential random variable, then its PDF is defined as, so fx of x is lambda e to the power minus lambda x for x greater than 0. Otherwise, it is 0. And if you find the CDF, the CDF is given as 1 minus e to the power minus lambda x for x greater than 0, 0 otherwise.
CDF
sorry.
is not
No, sorry,
0
sorry.
otherwise.
Yeah. So it is 0 for x less than 0, and then it is 1.
Yeah, that's okay. I think that's
Yeah.
okay. I think actually that's
Yeah.
okay. You could have said 0 otherwise, but it's probably better to write it on top than below.
Yeah.
It will anyway go to 1 if x becomes very large. So I think you don't have to write 1.
So probability x less than 15. This is nothing but the CDF at 15, right? Now this is given by, so for x greater than 0, it is given by 1 minus e to the power minus lambda x. So x here is 15 and lambda we know it is 1 upon 20. So this is going to be 1 minus e to the power minus 15 by 20. So this is our probability. This is what we found using the CDF. If we had to use the PDF, then we will have to go by integration. Right? So if you want to do it by PDF, then you have to find probability x less than 15. So it should start from 0 to 15 and you will have to integrate your PDF. So lambda, that is 1 upon 20 e to the power minus x upon 20 dx.
Just one quick question, Nikita. So the formula sheet, has it been shared with everybody? The formula sheet?
Yes, sir. Yes, sir. It has been shared with
It has been
everybody.
shared. It looks like there
Yeah.
are many people who have not seen it. As
Yeah,
usual, not very surprising. But please ask your friends. It's been shared with everybody.
Yeah, maybe some 1 week back or
Yeah,
2
yeah.
weeks back it was shared.
So is it in the supplementary content?
It is in the supplementary content. There's a formula file. So there you will get the formula file for quiz 1.
Oh, thank you.
Yeah.
So just curious, will this be given during exam?
Yes. So the formula file that is shared with you, the same formula file you will see during the exam also.
Thank you.
Yeah.
Ma'am, it is shared under short notes. in supplementary contents.
It is shared in the short notes. Okay.
Yeah, just in
Can you
case
put
somebody
the
is
description?
confused.
Yeah, you can put in the chat box also for reference.
Yeah, sure.
Yeah. Thank you.
Sure.
Madam, I have a doubt. Can you, in the question, it is given that less than 15, it is not less than equal to 15. So in this case also, we need to take the 15 values, or it should be 14. We need
Okay.
to
So exponential distribution is continuous
Yes.
distribution, right?
Yes.
So in that case, the inequalities doesn't matter. Either you take, so if you have to find probability x less than a, so this is going to be same as probability x less than equal to a.
Okay. Thank you, ma'am.
Yeah.
Yeah, but this is
But
true only for continuous
yeah.
random variables. Be very careful. And also one more statement you made got me confused, got me scared a bit, because see, you said probability that x less than 15, should you take x equal to 14, right? What about 14.5, 14.7, 14.99, 14.3654, whatever, right? So this is a continuous random variable. X takes all values on the real line, okay? Be careful about such statements. So
Yes, yes.
probability, what is probability that x equals 15, by the way?
0.
0. Okay, so remember
Yes.
that. That's so that is one confusing thing which I try to explain in the lectures. So continuous
With
random
infinite,
variables behave like this.
so with infinite precision,
Where it is given,
the
sir, it is
Yeah,
continuous.
yeah,
value
yeah,
will be 0.
yeah, yeah.
Yeah. Thank you, sir.
One doubt, ma'am, in this we can use this PDF formula to get this probability, or we can use this CDF one.
Yeah, you can, CDF will be very straightforward. And if you use the PDF, you will have to integrate.
Integrate, okay.
Yeah.
See, the value of the PDF, is it a probability? Supposing I take the PDF and evaluate it at 15, is that a probability? Small effects of 15.
That's the density.
Yeah, it's not a probability. Okay, so
Okay,
you have
sir.
to integrate the density to get a probability. Keep that in mind. These are subtle differences,
Yes.
but you should be clear that probability density and probability are two different things. Probability density can be greater than 1.
Yes.
I think I show that also in one example in the lecture.
Just coming to
Probability density we were discussing while discussing the support for X.
Yeah, yeah, yes.
Yeah.
All right. So in the second problem, we have to find what is the probability that Krishna will take less than 30 minutes, but more than 15 minutes to complete the race. Okay. So just do it here. So from this problem statement, what is it that we have to find?
We have to integrate e to the power minus lambda x dx from 15 to 30.
Otherwise, we
Without
can find the
integration
value of
also we can
probability
do
of
this.
x less than equal to 30, and then we can subtract this answer.
Using CDF
Okay.
formula also we can do
Yes,
this.
we can
You can
also
use
do
directly
Yes.
PDF formula, ma'am.
So yeah, that will be
15
easy.
less than X.
Yeah. So we had to find the probability that Krishna will take less than 30 minutes. So your X was a random variable. It should be less than 30, but it should be more than 15 minutes. So using the CDF properties of CDF, we know that probability X lies between A to B is given by fx of B minus fx of A. So the same thing we can apply it here, and we can write fx of 30 minus fx of 15. After this, just compute the value that it gets. Any doubt in question number 5? Anything that you want to know? Okay. So the same way we had computed the first part, you can compute the second part. It's just we have two separate terms. Okay.
Ma'am, in the previous question, could you please explain how to find the value of fx 30 and fx 15?
fx 30 and fx 15. Okay. So the probability that x lies between 30 and 15, this is fx 30 minus fx 15. This part is clear to you, is it? Is this clear?
Yes, ma'am. Yes,
okay,
ma'am.
This is clear. Now, since x is an exponential random variable, the series of x is given by 1 minus e to the power minus lambda x for x greater than 0. Okay, so fx of 30 will become 1 minus e to the power, lambda was what? 1 upon 20. So minus 30 upon 20 minus 1 minus e to the power minus 15 by 20. This is what we had done in the previous problem also.
Yes, ma'am.
Yes.
I got it, ma'am. Thank you.
Okay. All right, so question number 6, it says a player rolls 2 dice independently and earns ₹30 if both dice show even numbers. So we have 2 dice, and if both the dice show even number, the player will earn 30 rupees. Okay. Now the player will earn ₹20 if exactly one die shows an even number. So either on this die it is even, or the other die it is odd, or the other way. Okay. So if in such situation, like even, odd even, in such cases, the player will receive ₹20. And loses 10 if both dice show odd numbers. Loses 10 rupees if both dice show odd numbers. Find the expected amount earned by the player. So,
oh, so just a couple of words before you go into the problem. Once again, notice the word expected. Okay, it just shows up like a very normal word, but it's a very, very crucial word in that whole question. Okay, first thing is that. Next is if the word expected is not there, if you're looking at the amount earned by the player, right? In one throw, the amount earned by the player will actually be a random variable. It will take 3 values with some probabilities. Okay. The expected amount is basically expected value of that random variable x. So I think Nikita will start by denoting x as amount and
it can be random.
I'm sorry. Was there a comment? Okay, anyway, carry on, Nikita. I just wanted to point out that it's very similar to the previous question that we had in expected. So there is a random variable which is defined using as a result of an experiment, and expected value of that random variable is being asked.
So first of all, we'll have to define what is the random variable here. So we are interested in finding the expected amount earned by the player. So random variable here we can define as the amount that is earned by the player. So either this player can earn rupees 30 or 20, or the player can lose 10. It is minus 10 also. Now, for each of the x that your random variable x is taking, we'll have to find the probabilities, right? So,
Ma'am, there's another one, odd and even also plus 20, is it?
This is also plus 20. Like it says earns 30, both dice show even numbers. 20 if exactly one die shows an even number.
It's like OE, ma'am.
OE also 20.
So is it possible, right?
That is also possible. I did not write it here. Yeah, I did not write that here.
Plus or both.
Yeah. So corresponding to each of the values that your random variable is taking, what is the probability we'll have to find? Because to find the expectation, we should know the probabilities also, right? So what is the probability that your random variable x is taking the value 30? So it will
9 by
36.
9 by 36, ma'am.
9 by
36.
9 by 36. So how did you find 9 by 36?
By jotting down all the events and then figuring it out.
Okay. So
the 36 outcome.
Yes.
By writing down all the 36 outcomes and then figuring it out. Counting it.
Yeah. So out of those 36 outcomes, we'll see that those 9 outcomes will have the even numbers on both the dice. And the second case, when are we going to get 20 rupees? So this will
18 by
happen.
36.
Ma'am, how much I didn't understand this? 9 by 36.
Sorry.
How is that 9 by 36?
How is it 9 by 36? So you have a total of 36 outcome, right? So when you write the values that it takes, so one, you can write 1, 2, 1, 2, 1, 6. So just write down all the values that it takes. So once you count it, you will get total of 9 outcomes where both the dice will have the even number. Okay. So 20, the player will earn rupees 20 if in case when one is even, other is odd.
18 by 36, ma'am. The outcomes.
Okay, you are getting 18 by 36. And if both the dice show odd numbers, the player is going to lose 10 rupees.
9 by 36, ma'am.
36 again.
9 by 36 again. Okay.
Yes.
So how do you find the expected value of a random variable?
We should multiply with those 30 into 9 by 30, 9 by 36 plus 20 into 18 by 36 minus 10 into 9 by 36.
Yes. So here the minus sign, you will have to be very careful because many a times student take it plus and then the answer comes out to be wrong. So since the player was losing rupees 10 if both the die shows an odd number, so that is why we are taking that loss as negative here. Negative minus 10, negative 10. Okay. So 30 times 9 by 36, 18 times 20 by 36 plus minus 10 times 9 by 36. So
540 by 36, ma'am.
You are getting 540 by 36.
Which is
you
equal
can
to
check
15.
the calculation.
15.
15, ma'am.
Okay, it is coming out to be 15.
5.
Yes, ma'am.
So any doubt in this problem?
No.
Okay. question number 7. So it is given to us that your random variable x, you have a random variable x that is uniform in 2, 3. So yeah, one thing that you will have to notice here is that this is not a continuous uniform distribution. So this is a discrete uniform distribution. Okay. So x is taking the value 2, 3, and it is uniformly distributed. So each of the values here should take the value 1/2. Now, y given x equal to x. This is given to us like this models your geometric distribution with p 1/x. We have two values that your x is taking. Either it is 2 or it is 3, right? Now, if I have to find what is y given x equal to 2, so what distribution will it be? Can you tell me?
Geometric.
So what should be the parameter?
Half. 1/2.
1/2, right? Because this is given to us, right? That given any x, your distribution that your y follows is geometric 1/x. Now, since the x is 2 and 3, we have x to be 2 and 3. So given x equal to 2, your y will follow the geometric 1/2 distribution. And similarly, given x equal to 3, your y
Geometric
will
1/3.
follow geometric 1/3 distribution, right? The first problem we have here is what is the probability that given x equal to 2, y is greater than 5? So the question is, what is the probability that y is greater than 5 given x equal to 2? So given x equal to 2, we know that y will follow a geometric 1/2 distribution, right? And we have to find the probability that y should be greater than 5. So y can either take value 6 or it can take the value 7 or 8 and so on, right? So yeah, so we know that y given x equal to 2, this is geometric 1/2, and we have to find what is the probability that y greater than 5. So basically we have to find probability that y is greater than 5. So what should be the easier way to find the solution?
What you have written there? Geometry. Y
Sorry?
greater than 5.
Sorry, can you repeat?
What you have written? Probability y greater than 5 then equal to?
Ma'am,
geometric
it's geometric distribution with parameter 1/2.
The sign called tilde, so it is geometrically distributed. Yes.
Okay, can somebody, one person tell?
Y less than 5. 1 minus y less than 5. Given x is
Less than equal to 5.
Can't we use a direct formula which we have for that summation of y for geometric distribution of summation over greater than p, that is 1 minus p power k?
Yeah, we have that formula, right? So, okay, can you tell me the formula?
1
If
minus
p is the probability.
5.
So just one
But
quick
y
point,
is greater
Nikita. I
than
think
5, right?
one point I would like to make, just y given x equal to 2 is geometric half, right? But the next one, you've said something there,
Yeah.
which I think somebody else also asked. I think that point was not clear. Probability that y greater than 5 given x equals 2 is what you're asking, right?
Yes, 5
I
greater
think we
than
have to
5.
divide it by
Yeah.
p of x equals to 2.
Is okay. Yeah, using the geometric half distribution, you want to compute probability that y is greater than 5 given x equals 2. Is that right?
Yes, sir.
Ma'am, can you share an example of where this will apply? For example, we had the combination of this Poisson distribution and binomial. Like, for example, in an hour, 20 people are coming into a store. And from there, we find out with binomial how many are men, how many are women.
So this is just a quiz question, you know. I mean, it may not have a very direct application, but eventually this kind of dependency will show up in some places. Don't ask for applications for each of these things.
Okay.
This is just for us to test whether you know how to deal with conditional distributions, how to compute probabilities for those things.
Okay.
So the application is testing your knowledge. Is that okay?
Yeah.
Yes, sir. Okay.
Yeah, so I think the notation is a bit confusing always. You have to think about that very carefully here. I think Nikita's also the writing is a bit confusing, no? What do you think?
So you're able to understand.
Okay.
It's very it's a bit dicey. So somebody else was talking about a division with x equal to 2. That also got me a bit worried.
Sorry, I got confused there. I
Ah.
thought we were solving second question where we had to take summation of x equals to 2 and x equals to 3. Basically
yeah.
getting joint from a conditional. Sorry for that. In this question, it's just 1 minus p per k, which is nothing but 1 minus here x equals to 2. So
Something like
geometric
that is the
distribution is.
answer.
Yeah.
Yeah, that's correct.
Yeah, sorry for confusing everybody.
Yeah,
I
so
think here it is half to the power of 5.
half to the power of 5.
Yes,
So
Minus speed. Ma'am, in this y greater than 5 doesn't play any role, or is it just we have to find the probability of x equal to 2?
can you repeat it again?
I'm saying, ma'am,
Yeah.
the y greater than 5, is it playing any role here in this to find the probability? Because x equals to 2, it's geometric 1 by 2. So if we take the formula of geometric.
Oh, wait.
Okay.
You're saying too many things very fast. Be very slow and careful, okay?
Sorry.
See, x is a random variable. It takes two values, 2 and 3, with probability half each. Okay?
Yes.
Keep that aside. Okay. There is some joint distribution between x and y. Okay. How is that specified? It's specified through the condition, the marginal of x, which has been given already, and the conditional distribution of y given x equals 2 and y given x equals 3. Is that okay? So y given x equals 2 is already, somebody has computed all the joint by marginal and all and concluded that it's geometric half.
Yes, sir.
Okay. So now look at the first part of the question, right? Now it says, what is probability that y is going to be greater than 5 given that x is 2? Given x is 2, y has a geometric half distribution. So in the geometric half distribution, what's the probability of having a value greater than 5? That's the question 1. Okay.
Sir, one query over here. If y is greater than 5 over here you are written, shouldn't it be 1 minus, what the probability is 1 minus y is less than or equal to 5 given x equal to 2. So shouldn't it be 1 minus whatever is the geometric probability, like calculation?
Yeah, that's exactly correct. That's what she has written there.
Okay. I actually got confused.
So maybe you should write it like that, Nikita. You should write it as 1 minus like that, so that it's clear where you got it from.
And so this k is representing the 5 number. Sorry. This power 5 is coming from y greater than 5, right?
Yes, yes, absolutely.
Yeah.
Yeah, the 5 is very important. Without the 5, you won't get the 1 minus p power 5. Now the question is, should we divide this by probability that x equals 2? Let me ask that question. Somebody asked it and withdrew it. Now I want to ask. Should we divide this 1 minus p power 5 by probability that x equals 2?
No.
No.
That's clear to you, right? Because the conditional distribution itself is given as geometric. Okay. So
Yes.
be a bit careful about that. So somebody has already divided and then told you the distribution is geometric.
It's already given geometric. We don't have to use the.
Sir, I didn't get your question. Please, could you repeat?
No. See, normally when you do probability of A given B, what do? You find
Joined by
probability of
marginal.
A intersect B, divide by probability of B, right?
Yes.
So why are we not doing that here was my question.
Yeah, mine question too. What is the answer?
No. So basically this conditional distribution is directly given to you. Y given x equals 2, the distribution of that itself has been given to you, right? So for instance, if you take probability that y equals k given x equals 2, right? What will that be? Probability that y equals k given x equals 2. It's 1 minus
1 minus
G.
1 minus half power 4 times 1 by 2, right? So it's basically already given as geometric. So that's the meaning of saying, maybe you should scroll up a little bit, Nikita, just a little bit. Can you show the what is specified? Up. Yeah. So what is the meaning of y given x equals x is geometric 1 by x? Basically, that's the question.
Okay.
Right? What is the meaning of that? So supposing if x is 2, what is the meaning of saying y given x equals 2 is geometric 1 by 2? Basically, it means probability that y equals k given x equals 2 is
Geometric 1 upon k.
Yeah, so probability
1
that
upon 2.
y equals k given x equals 2 is 1 minus p power k minus 1 times p. Right? What is that p? That is, in this case, it's half, right?
Right.
So that is the meaning of that statement.
Thank you.
Sir, can you explain in this formula 1 minus half to the power k minus 1 into p, what role this 5 plays greater than 5 plays? So we have a formula for y equal to k. So how we put it in this formula?
So if you want to say greater than 5, you have to now add for all possible values of k which are greater than 5, right? So k equals 6 is there, 7 is there, 8 is there, etc. So you will be adding summation k equals 6 to infinity, 1 minus half power k minus 1 times half.
Yes.
Right?
Yes, sir.
So you can calculate it like that. So that will give you an answer.
Okay.
So in that case, should it be 1 minus just the p raised to 5?
I'm sorry.
Can you repeat?
In that case, shouldn't it be 1 minus just the p raised to 5, because we have to subtract that particular thing from 1 now, because it's y is greater than 5, so it should be 1 minus. So
it will be 1 minus the CDF of geometric half evaluated at 5.
Okay.
Right?
Yeah.
Which is, I mean, it's also the same as adding up the PMF from 6 to 6, 7, 8, so on, right?
Right.
Yeah, that's the point that was made.
Okay.
Okay.
You write it.
So maybe Nikita, can you write this out in full detail?
Yes, sir,
probability
please.
that
Yeah.
y greater than
Solve
5 given x equals 2, or probability that y equals k. I think maybe you should write that first. Probability that y equals k given x equals 2. Yeah. This is
1 minus
1 minus half.
So this is a geometric 1 by 2.
No, geometric
1
1 by
minus
2
p to the
evaluated
power
at k. Yeah. 1 minus p. Yeah.
minus 1 to p. So
So
p
and
is
this
half
p
here.
is half. Yeah.
This is again half.
Half. Yeah. So I think don't say it's geometric 1 by 2. Geometric 1 by 2 evaluated
Yes.
at k. The PMF evaluate, yeah, distribution is like that. So this is what this is. Now, if you want to do probability in the next line, if you can write probability that y is greater than 5 given x equals 2, yeah, it's summation from k equals 6 to 6, 7, 8, so on.
6 to infinity. And
half power, whatever, you've already simplified it, yeah. K minus
so
1
k
times
minus.
half.
We can write that as half to the power k directly.
Yeah, half to the power
Yeah.
k, yeah, absolutely. So
This
you'll
would be
get
better.
you can sum the geometric series and get the answer. That's perfectly valid. You will get what? Half power 6 divided by 1 minus half. That will be half power 5, right? I think is this the question that was asked? The answer is half power 5, right?
Yeah.
Yes.
Okay.
Yeah,
In that case, so we have to approach it only in this way, in this case, because what I was confused with is, since it's y is greater than 5, I should consider y is less than or equal to 5 given x equal to 2. So I have to subtract it from 1.
So you can also do 1 minus probability of 1 minus summation k equals 1 to 5 half power k. You can do that also.
Okay, it will come
Both will give you the same answer.
Okay.
How can the answer differ? It will be the same answer.
Yeah, thanks, sir.
So the same way you have to find for probability y greater than y. Probability y greater than 5. Now, how will you do this? So we know the distribution for y given x equal to x, right? So you have two possibilities for x equal to 2 and x equal to 3. I will just write it here. So the second problem, you have to find what is the probability that y is greater than 5. So this expression, we can write it as probability y greater than 5 given x equal to 2 times probability x equal to 2. And then your x is also taking the value 3. So we can write probability y greater than 5 given your x is taking the value 3 times probability that x is taking the value 3. So x equal to 2 and y equals to 3. These probabilities are already known to us, right? Because they are uniform in 2, 3. So their probabilities are going to be half. And the same way we had found for probability y greater than 5. So this is already we found. And probability y greater than 5 given x equal to 3. This we can find the same way we did this. So if you do this, you will get here. So this term will become sum over k varying from 6 to infinity 1 by 2 to the power. Sorry, this is going to be 1 by 3.
No, it will be like 1 minus 1 by 3 per k minus 1.
Oh, yeah, right. Yes, thank you.
Be slightly careful.
Yeah. So it is your 1 minus 1 by 3 to the power k minus 1 times 1 by 3. So this becomes your 2 by 3 to the power k minus 1 into 1 by 3. Okay. So you just have to sum these both terms and we can find our probability y greater than 5. So if you write the total expression, it will be 1 by 2 to the power k times 1 by 2 plus 1 by 2 times this expression.
Can you also tell how to expand and solve this, the second part?
How to, you mean the
2 by
answer?
3 raised to k, yes, that whole summation part.
Okay, how to do this?
Yes.
All right. So, okay. You'll have to just keep substituting the value. So for k equal to 6, so this will become
No,
5.
that will become a series, I understand.
Yeah.
But that series, that geometric series will have some formula to resolve. No, I want that step.
This will have
till infinity we cannot add. We cannot add till infinity.
You will have an infinite series, right?
Yes, exactly.
So sum of that series we give by a upon 1 minus r.
And r is 1 by 3 here?
That we will have to see. So, okay. If you put k equal to 6 here, it becomes 2 by 3 to the power 5, 1 by 3 plus 2 by 3 to the power 6, 1 by 3 up to so on. So we can take common as 2 by 3 to the power 5 and 1 by 3. This we can take common, correct?
Yes.
So this becomes 1 plus 2 by 3 plus 2 by 3 whole square. It will go on till infinity, correct? So
yes.
What is a here?
A is 2 by 3.
1.
A is 1 here.
A is 1, sorry. A is 1, R is 2 by 3.
R is 2 by 3. R is 2 by 3. So once you
Yes.
substitute in this formula, you will get this sum. Right?
Yes.
So it will become 1 upon 1 minus 2 by 3. That is 1 by 3. So it will become just 3.
Okay.
Correct. So these will get cancelled out and you will just have 2 by 3 to the power 5.
Okay.
Right?
And could you please scroll a little bit up?
Scroll up, okay.
This one, ma'am. I'm really sorry, may appear a very silly doubt, ma'am. In the previous case, when we talked, no, be here only, ma'am, be here only.
Okay, yeah.
Yeah, in the previous case, when we talked about conditional probability, in that case, we had not multiplied by probability equal to probability of x equal to 2, right? But in this case, in both the expressions, we are multiplying by, probability of x equal to 2 and probability of x equal to 3. So this part I am missing. Apart from
We are using a law of total probability actually to find out the y greater than 5.
Yes.
Ma'am, can I say different representation of the same thing, ma'am?
Different representation of the same thing.
I mean, we can do this in table format, like we can write all the y values above and x values below.
Right, all the y values, okay.
For the second question.
Yeah.
I mean, it will be more understandable if we do it like that from table method.
From table method.
Yeah, you can do table also. Yeah. I was about to suggest that if this is confusing to you, you can look at the table. Table will go x.
So
x will take only two values. 2 and 3. And then y will go from. Yeah, so y will go.
6, 7, 8.
No, need not be 6. You should start from 1, no?
No, yes, sir. In general, y like 1, but for this problem, I will write from.
Yeah, but you can start with 1 just to show the full table. 1, 2, 3, it will keep on going, and you can write the probabilities for each of those. You can do like that also. Oh, now Nikita has erased all that she wrote. Now people will be totally confused about the first method. So you can write using table. I think, I mean, if this is not so
Very
clear, you can
confusing.
look at it. So now if you want probability y greater than 5, you have to add up the whole thing. And,
All the joint PMF.
yeah, joint values you have to add up. So you can think of it like the table also. It's nothing but the table in some sense. What will come in the x equals 2, y equals 1 place? What will be the value there? So the first top left position,
half?
right? X equals 2, y equals 1. What will it be? Yeah, what will that value be?
1 by 2.
1 by 4. 1 by 4, I think.
Yeah. So what 1 by 4 I also think is correct, but why is it 1 by 4?
Sir.
Yeah,
It's
because,
1 minus half raised to k minus 1 into p. If we do that,
yeah.
half
So
into
basically,
half.
what is that box? What value should come on that box?
1 by 4, sir.
What probability should come on that box?
1 by 4.
Probability that
Probability
y equals to 1
that
and x equals to 2.
Yeah, probability that x equals 2, comma y equals
Y
1,
equal
right?
to 1.
So that is the same as probability that x equals 2, comma y equals 1, right?
Yeah.
So that is the same as probability that x equals 2 times
Conditional
probability that y equals 1 given x equals 2, right? So now x equals 2 is half. Now what is y equals 1 given x equals 2? You use your geometric distribution formula, you will get something. Half you will get, right? So half into half is 1 by 4. So this is the method the other person was suggesting, that you can write down the whole thing in a table and then observe the pattern, and then when you add it up, it will be very clear is what he thought. Maybe it's confusing to some people. You can do it like that also. So part 1 will be one part of the summation. Now if you do y equals 5, y greater than 5, you have to add up both things. Okay, but let me I mean, keep the table part aside. If you're not understanding it, it's okay. You can come back to this expression, and this law of total probability type thing you can write. Basically, so the way at least I like to think of it is, you can write probability that y greater than 5 as probability that y is greater than 5, comma x equals 2, plus probability that y greater than 5, comma x equals 3. Is that okay?
Okay, sir.
So that I think is the first step, and then you will get the second step that Nikita has directly written. Okay, probability that y is greater than 5 is actually probability that y is greater than 5, comma x is equal to 2, plus the probability that y is greater than 5, comma x equals 3. Okay, so that's important, and then you will get this step. So from there you can see why the multiplication from x equals 2 is coming. Okay, so that was the question, right? The person who
Got
asked
it,
the
sir. Thank
question
you. Yes, sir. I asked.
was
Thank you,
asking
sir.
where the multiplication of x
Correct.
equal to 2
Correct.
came from.
Correct.
In the first part, already you are only computing the conditional. In the second part, you're computing y greater than 5, and that is splitting into the sum of two things. And then each of them, you use the joint probability of A intersect B, and then you get this.
Thank you, sir.
So we also have a third part here.
So yeah, just to make one slightly maybe a funny remark for me, but maybe not too funny. I think it was Vijay or someone who asked, what is the application of this question? I think the very good application is it tests your understanding of joint PMF and how to compute probabilities using joint PMF, right? I think most of you will agree with that statement. So the application is that. But yeah, I think it can be a bit confusing. But think about this a bit more, and if you get to the bottom of this question, some clarity will emerge on what the joint distribution is.
It was a very good question, sir. So it was confusing also. So that is
Yeah,
the reason why I was trying to
yeah,
pitch
yeah.
there is any application.
Yeah, associate it with the table, okay, and I think make sure you understand how the same answer comes from the table, and how this this total probability law is coming and all that. It'll help you a lot.
Yeah.
One last remark. In the first part, we'll not multiply it with half because here conditional probability, we are not calculating conditional probability, but geometric of 1 by x. Is it correct?
I wouldn't put it that way. I see in the first part, you are asked for probability of y greater than 5 given x equals 2, right? In the second part, you're asked for, okay, so let me ask one thing first. Between the first and second part, there is one more part, okay? What will you say if I ask you for probability that y is greater than 5, comma, x equals 2? What's the answer to that?
We'll plus add the probabilities.
See, first thing you have to understand is, I think, I'm not sure if I emphasize that in the lecture a lot. I think I probably do. What does that comma mean in joint probability calculation? And okay, and remember it is and. Okay?
Multiplication.
So yeah, so it's and. Let me not say multiplication. It's and. Okay.
And
probability that y is greater than 5 and x equals 2. That is very different. That's intersection, right? Probability of A intersect B. See, once you start doing random variables and distributions, people tend to forget the basic events and formula. The part that I always say about probability is every probability problem has only the same method, the same, that and rule and or rule, and that's the only thing that is ever there. So even here, it's the same thing. You know, probability that y greater than 5, comma, x equals 2, right? It's probability of y greater than 5 and x equals 2. It's the probability that x equals 2. See, probability of A intersect B, how do you write? Probability of B times probability of A given B, right? The same thing you can do here. And the exact same thing you'll have to do. Okay. I hope that part is clear to you. So probability of y greater than 5 given x equals 2, you've already computed. Now, if you want to find probability of y greater than 5, comma, x equals 2, that comma is nothing but and. So you'll have to multiply this guy with probability of x equals 2. Is that okay?
And for last question, it is a geometric progression. For third question, it is.
We will come to that slowly. You know, wait.
Got it, sir. Thank you.
Is that okay? Be careful about that. So now,
yes.
Now, if you remember, there is this law of total probability also comes in the second part, right? Probability of y greater than 5. You don't know the distribution of y directly, but you know the joint distribution of y and x, right? So you use the law of joint probability and decompose that event y greater than 5 into the disjoint union of two events, right? What is that? Y greater than 5, comma, x equals 2, right? Union y greater than 5, comma, x equals 3, right? Once you do that, you write probability for the union. Now you know it's a disjoint union, so you can write it as probability of y greater than 5, comma, x equals 2 plus y greater than 5, comma, x equals 3, and then you're back to using the same, conditional and all that. So just because you suddenly have random variables, the basics are not forgotten. Okay, the basics are still the basics. The using the and the or and the union is everywhere. If you forget that, then you'll have to relearn all these things. But if you keep remembering that, it will fall into place for you. Okay.
Sir?
Yeah.
Just one slight element of doubt, sir. That comma means and, sir, and that expression is clear now. Just one element of doubt is coming when we are saying probability of y is greater than 5. comma x equal to 2.
Yeah.
Doesn't it mean that it means x equal to 2 is already given, so it is conditioned that probability?
No. It's and. Don't get confused by that. It's and. Okay. It is actually conditioned. You see, probability of A and B is always probability of A multiplied by probability of B given A. Okay.
Yes.
It's not conditioned. I know that's the difference between English and probability theory, right?
Yes,
In
sir.
English, you probably are thinking all of these are the same. Okay. But when you write probability statements, A and B and A given B are two different things.
Sir, if I may add one thing here. If X and Y had been not related, then probability given X given Y would have been the same as probability of X.
Yes. If A and B are independent, probability of, when you say related, it's a vague word. It's not very well defined. If A and
Yes,
B
sir,
are
related.
two independent events, then probability of A intersect B is probability of A into probability of B. The same thing will apply here. If X and Y are independent random variables, probability of Y greater than 5 comma X equals 2 will be probability of Y greater than 5 times probability of X equals 2. If they are independent. But in this case, they are not independent. Okay. X and Y are not independent. Is that okay?
Yes, sir.
Okay. I think you can now answer the third question, Nikhil.
Okay, so the third problem we have here is like whether y is a geometric random variable or not. So how do we check this if y is a geometric random variable? The information that we have is just what is the distribution of y given x equal to x. So I will just move this part here. So we have to check whether y is geometric or not. Now, if you take any y, right? So if I'm saying, let's say y is a geometric random variable with some p. So if this happens, then for any k that y takes, it should be 1 minus p to the power k minus 1 into p, right? So for any general k, if I try to find this probability, so this will be what? This will be, as we have seen in the previous case, like we had find for probability y greater than 5, right? So here we can find for probability y greater equal to k given x equal to, same law of total probability will use. So given x equal to 2 into probability x equal to 2 plus given x equal to 3, what is the probability that y takes the value k into probability that y takes the value 3. If you compute these probabilities, what do we get? In this case, so we got this as 1 by 2 to the power k into 1 by 2 plus this will come out to be 1 by 1 minus 1 by 3 to the power k minus 1, 1 by 3, right? Into 1 by 2. Probability y equals 3 is 1 by 2. So if you solve this, will you be able to write this expression in the form of some 1 minus p to the power k minus 1 times p? Is it possible to write this in this form? 1 minus p to the power k minus 1 to the power p. Anyone?
Yes, it is possible.
It is possible. Can you try?
Yes, excuse me.
Yeah.
I didn't get what you say.
Okay. So can we write this in the form of 1 minus some p to the power k minus 1 times p? Because
Yeah,
we are
we can write
finding.
it.
Okay.
We can do. We can take half common, and then
Okay,
we can write
let's
it as.
take half common.
We can't, I think.
Let's take half common here. Okay.
Then
we'll have 1 by 2 to the power k.
We
I think we
2
can't
by
write it.
we can't
I
write
don't
it.
think we can write in
we
that way.
can't write
No,
it.
ma'am, we cannot try.
Yeah, we can't write it. I
Yes.
forgot that was
So-
1 by 2 to the power k.
We will not have any such fixed p for which you can write this expression in this form, right? So we cannot say that it is a geometric random variable. Because if in case y follows a geometric random variable, the probability that it should y should take the value k, it should be of the form 1 minus p to the power k minus 1 into p, where p is fixed, right? And p is the probability of each outcomes that you get, right? Like for each try. But this is not fixed. Like we cannot identify what is the value of p from this expression, the last expression that we have written here. So we cannot say that y follows a geometric random variable. So this is no. Anything that you want to ask from this?
Like visualization, how do we do? Like only from mathematically we need to calculate whether we are able to write this equation, and if it is yes, then we will say. Or is there any visualization technique that we can come to know from the, let us
So
say
you
I'm
can
giving a question.
you
let us
can
say
sort
one
of
problem.
prove it if you want to be very rigorous about it. If you scroll down, Nikita.
Yeah.
See, for geometric distribution, if you take probability of y equals k plus 1, right? It will be 1 minus p times probability that y is k, right?
Yeah.
Every successive probability will be multiplied always by 1 minus p. So you can take probability of y equals 1 and then y equals 2 and y equals 3 and show that the common ratio is actually not the same. The ratios are not the same. They are not common. So that way you can clearly, sort of prove rigorously that there can be no p for which this expression that Nikita has got here can be written as 1 minus p per k minus 1 into p. Is that okay?
Sir, can you please repeat this one? I could not get the.
Yeah,
because
so
it's
maybe you
not
should write
repeating.
that the
Yeah,
probability that y equals 1 is explicitly, if you evaluate, you're going to get
come out to be 1 by 2.
5 by 12, I think. Then probability that y equals 2. It's a bit of a pain, but you can sort of do it. You can give bonus marks for anyone who quickly comes up with the answer.
17 by 72, ma'am.
What is it?
17 by 72, sir.
Okay, 17 by 72.
72. Okay.
Then you can do y equals 3.
3.
And then show that the ratio is not common. Okay, it won't be common. I think this ratio is some. That won't be something else. Okay. Yeah, I think that people can take as an exercise. Yeah.
Sir, or we can do the alternate way in the probability of y equal to k plus 1. The probability is 1 minus p raised to k. We can put the value of k as 1. So we will get 1 minus p raised to 0 into p. So in that case, we can show that it doesn't matches with what we have already calculated for y is equal to 1.
Yeah, you can
Yeah.
even do it with y equals 2 also if you like. Yeah, so 17 by 72 is not the same as 1 minus 5 by 12 into 5 by 12. That's what you're saying, right?
Yes, sir. Yes, sir.
Yeah, so you can write that. You don't need y equals 3, Nikita. Maybe you can
Yeah.
just go there and say this is not equal to
this. Yeah.
1 minus 5 by 12 into 5 by 12. That's enough. No, y equals 2, no?
Okay. Yeah, y equals 2.
It's not equal to 1 minus 5 by 12 into 5 by 12. So this clearly shows it's not jumped. Okay, are we close to the end? Is it done or halfway?
There are 3 more problems, sir.
Okay, so I'll have to leave at this point. My kids are hungry. I have to make dinner for them. I hope it's okay. I'll
Yes,
happy solving. Enjoy the rest of the mock exam session. Okay.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Bye.
Thank you, sir. Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Sir, excuse me, sir. Hello.
Left.
Thank you, sir. Could you explain once again how we have calculated the probability y equal to 1 equal to 5 by 12?
Okay, I will write it again. Wait.
Ma'am?
Yes.
Ma'am, can we get this notes in the supplementary content?
What we have done just now?
Yes, ma'am.
Okay, I think
And
just
this solution will be released tomorrow, or it will be
solution.
take
I
time?
will release this. What we are doing it now. I will release this. I hope this is clear enough.
Yes,
No,
ma'am.
I mean the official solution will it be released tomorrow, or
official
will take time?
No, we'll upload this only. So I hope everything is done here.
Because
like if
that-
something is not clear in this, I will just write it again and upload this part. Okay.
Yeah,
This
this
will be more clear.
specifically
Than,
that geometric one is.
I will write. I have also erased many things there. So yeah, I will just write it again and upload this again. All right. So yeah, what we were discussing here is like if you have to take y equals k plus 1, right? So if y is geometric, this was when y was geometric p, then probability y equals k plus 1 will be 1 minus p to the power k into p, right? Now, this is the expression that we got from solving this probability y equals k. We were trying to find probability y equals k, and since x was taking the value 2 and given x is taking the value 2, y the distribution of y is geometric 1 by 2, and given the x is 3, the distribution of y given 3 is 1 geometric 1 by 3, right? So using the information that was given in the problem, we came to this expression here, the expression that you see in the orange. So the expression that you see in the orange box here, this is what we obtained. Now let's try to find the probabilities from here. So this is for in general sum k. Now if I want to find it for, let's say, y equals 1. So what will this value be? It will be 1 by 2. So 1 by 2 to the power 1. So again 1 by 2 plus this is 0. So something to power 0 is 1, and this is 1 by 3. So this becomes 3 by 6 plus 2 by 6. 3 plus 2 is 5. 5 by 6, that is 5 by 12. Is it okay?
Yes, ma'am, got it.
Got it. Similarly, you find for probability y equals 2.
Yeah, I can do that now.
Right? We got something like, I forgot. So something 72, I guess. Then what you will do is to check whether it is geometric or not, you will use the actual probabilities that you get from geometric B and check from here. So you have probability y equals k plus 1. So you put k to be 1 here. So probability y equals to 2 from here becomes 1 minus 5 by 12 times 5 by 12. So this doesn't comes out to be 17 by 72. So this is one way to check that
Ma'am,
this is not a
P is half, no, not 5 by 12.
P is
Half.
No, for
here
y
it
equals to
is
1, it's
Y is equal to
5 by
1, that
12.
will be the P, right?
No, no. When you have put in this formula, K has a value of, say, for example, K has a value of 1. And then for Y equal to 2, then we will put the same K as 1 in this 1 minus P raised to K, no? P, the value of P won't change for both cases.
the value of P won't change for both cases. Which case you're talking about? This one?
On the right hand side, we have calculated, yeah.
Yeah.
Here also, the value of P is half.
The value of P is half. We
Small
don't
p,
know,
small p,
right?
small p.
We don't know. We don't know what P is here.
Okay.
So basically what we were trying to say is, like, if you find y equals 1, y equals 2, y equals 3, y equals 4, and so on, you will see the common ratio that you will get, like 5 by 12, 17 by 72, and whatever you get for y equals 3. If you look at the terms, the common ratio won't be same. So this is why also we can say this is not a geometric random variable. Because to follow a geometric, it should follow geometric series also, right? But in this case, it won't follow. So this is not a geometric. Yeah.
I will take in less than 1 minute, ma'am.
Yeah.
For part 2 of this question only.
Part 2.
Yeah, this one. Probability of y is greater than 5. Can you write, ma'am, what I'm saying? Probability of y is greater than 5. Probability of y is greater than 5.
Okay.
Now it's a combination. It may be a combination of two cases equal to probability of y is greater than 5.
Okay.
Conditioned on x equal to 2 plus next probability of y equal to 5.
Y equals to 5.
No, greater than 5. Sorry, greater than 5. Conditioned on x equal to 3.
Okay.
Right. Now the first expression becomes a geometric distribution with probability 1 by 2.
This here you are missing the part that it is into probability x equal to 2 into probability x equal to 3.
Exactly.
You are missing this part.
No, I am just taking the help of the guidance given at the top of the question, that probability of y given x equal to x follows geometric distribution, right?
Yeah, probability y given some k given x equal to x follows geometric distribution.
1 by x. 1 by x.
Yes.
So I am taking the help of this information. So why I can't write like this? Because we solved part 1 with the help of this this method only, right?
But in part 1, this is what sir had also explained just now, that in part 1 that we had to find probability y greater than 5 given x equal to 2. Correct. And this follows your geometric 1 by 2 distribution.
So in part 1, x equal to 2 was given, right? But here, the value of x is not given. Correct?
Okay. X is,
there are two possibilities. Now my x take
that is right. That is right. But you look at the table again. Where's the table? So what do we mean by probability y greater than 5? So x is taking two values, 2 and 3, right? And y greater than 5 means y can take the value 6, y can take the value 7, 8, 9, and so on. But if you look at any particular joint distribution, right? So this box here. So this gives you the probability that x is taking the value 2 with y is taking the value 1. Right? But we don't know the joint distribution. And we know that given any xy, if we have a joint distribution, let's say fxy, then probability x equal to x and y equals to y, this can be written as probability x equal to x given y equals y times probability y equals y, right? This we know. So we have to go for each of the probabilities, correct? We don't know what is the joint distribution, but this we can find using the conditional times the marginal. And all these we'll have to add. So all these terms that it takes, like probability, if it starts from y greater than 5, it means we are interested in finding the probability that y is greater than 5, comma x equals 2. Sorry, y, it's stated y equals 6, comma x equal 2, plus probability y equals 6, comma x equal to 3, plus probability y equal to 7, comma x equal to 2, and so on. Everything we want.
So here we are taking both the values of for x, not 2 and 3, right? And in the first case, the value was given as 2 only. So in that case also, it could have been that probability of y equal to 6, x equal to 2, probability of y equal to 7, x equal to 2, right? Because it is also y is greater than 5. Na? In question number 1 also, it is probability of y is greater than 5, right?
Yes.
In part 1.
Part 1, yes, it is probability x greater than 5, given x equal to 2.
Greater than 5, x equal to 2.
Yeah.
In this case, we simply took the geometric distribution as 1 by x.
Because it is given to us that y given x is following the geometric 1 by x distribution.
The second line is the common information for both the question. No? The second line is the common information.
Second line
is this let y condition.
Okay, yeah, this is the common information. This is a common information, right?
Okay, let us move to next question.
Yeah, one thing you can do is like we had just discussed this problem, so maybe you can watch just that clip on the YouTube.
Yes, we can move to next question.
Okay.
Ma'am,
yeah.
Can we say that individually, if we take x equals to 2, as Ganga Prasad was mentioning, so can we say that if we take x equals to either 2 or x equals to 3, individually they are modeled as geometric distribution, random variable with geometric distribution, but when we talk about the joint distribution, we cannot arrive at the p factor. Is that correct?
We cannot arrive at the
p, geometric p, when we take the joint distribution.
Okay.
Is that correct to say?
You're not talking about the third part, right?
A third part only.
No.
Ganga Prasad
was asking for the second question.
That's true, ma'am. For second question, when he was saying,
the
argument that he put up saying that if we take y greater than 5, given x equals to 2, plus y greater than 5, given x equals to 3.
Yeah.
So if we take individually, they are modeled as geometric random variable. But if we take it as joint, then it is not a geometric.
It is not a geometric random variable.
Is it correct to say so?
So you mean probability y greater than 5 given x equal to 2 plus probability y greater than 5 given x equal to 3.
Yeah, if we take it as joint,
this cannot this we cannot
then
say
it is
that
not,
that this follows also geometric distribution.
Because the p is not common.
Yes, this is my argument only. Yes, correct.
Because we do not have a common p. That is what I understand. I'm not sure if my understanding is correct.
This is not geometric. This is not geometric for sure.
But in isolation, they are geometric. But in isolation, they are geometric.
But the individual term,
yes,
these
they are geometric.
These we know.
Yes. Well, this may be one of the explanation, I think. So it's absolutely right, I think.
Okay, this was your doubt.
Yes, that's what I'm saying. Na?
Okay.
This is what I'm saying, that individually they are following geometric distribution.
Okay.
Right?
I thought you were asking like, can we not write it this y greater than 5? Okay then.
Okay, we can move to next one.
Yeah. So the next problem is from the Chebyshev's inequality. It's okay. So what all information is given to you? The distribution of heights of students in a certain school has mean of 150 centimeter and standard deviation of 10 centimeter. We know that, so let's say you have a random variable x that gives the distribution of heights. Distribution of heights. And it has a mean of, let's say, the mean of x is given by mu, and it is 150 centimeter. And standard deviation of x is given as 10 centimeter. Use Chebyshev's inequality to find the probability that a randomly selected student from that school has a height of either greater than. Now you randomly pick a student from that school. So since your random variable x gives the distribution of heights of student, so once you pick a student from the school, what is the probability that this student has a height either greater than or equal to 180, or it is less than equal to 120? You have to use the Chebyshev's inequality. So what does the Chebyshev's inequality says?
It says the difference between the random variable and the mu, if it is greater than some k standard deviation, then the bound is less than or equal to 1 by k square.
K square, right. So in this case, we know our mu is 150. Right? Standard deviation, we know it is 10. If we extend this, we will write this is nothing but x minus mu greater than k sigma and minus of x minus mu greater than equal to k sigma. So from this expression, the first one, you will get x is greater than equal to mu plus k sigma. And from the second expression, you will get x is less than equal to mu minus k sigma. Right. So if you have a mu here, this is mu plus k sigma, and this is mu minus k sigma. Now, if you look at the question, there you have to find the probability. So start your x is greater than equal to 180 and less than equal to 120. So this mu plus k sigma should be equal to 180, and this mu minus k sigma should be equal to 120, right? And mu is given to us, that is 150. From there we can find k because sigma is also known to us. So what will the value of k?
3, ma'am. 3. 30 by 10, 3.
Okay. So k you will get as 3. Now once you substitute it there, so it becomes 1 upon 9. So it means probability that a randomly selected student will have a height of either greater than 180 or less than 120 will have a bound of 1 by 9.
Means at most 9, no ma'am? 1 by 9.
At most 9.
Right. 1 by 9. Yeah.
Probability should be less than equal to 1 by 9. So it cannot go beyond 1 by 9. It should be less than equal to 1 by 9. So we'll say it is at most 1 by 9.
Ma'am, I have a similar question, ma'am.
Okay.
It is in the previous year's question paper.
Okay.
So I just post it in discourse, ma'am. Can you help me with that, please?
Can you post it here in the chat box? I'll just have a look.
Yeah. I'll do that once again.
Ma'am, how it is 1 by k square?
How is it 1 by? This is your Chebyshev's inequality.
The equation, right?
Okay.
Yeah, this is your inequality. So one more thing that you can, there is another way to write this.
Ma'am,
yeah.
This 1 and greater than 100.
Your voice is breaking. Can you Can you repeat?
X less than 120, ma'am. When that X less than 120, how do you put here?
I'm not able to understand. I'm not able to understand.
He's asking how do you put mu minus k minus 120? I think that's what he's asking.
Oh, how do I put the mu plus k sigma to be 180 and mu minus k sigma to be 120?
Oh, no, ma'am, that I understood. That I understood. But so ma'am, this value, I could not understand the calculation part. How did it come? Like
K equals 3.
yes, ma'am.
Okay.
Like mu plus k sigma is equal to 180, right? Mu is
Yeah, so mu is given, that is 150. And sigma is what? 10. It is given to us. So 10k.
Okay.
This
ma'am,
is 180. So it will get k equals 3.
Thank you.
Okay. Let's move to the next question. All right.
Ma'am, can I ask a question regarding Chebyshev?
Yeah.
Question, ma'am. This question came out one of the slides. That was
one of the slide. Okay.
It says that suppose a fair coin is tossed 200 times, find an upper bound for the probability that more than 150 heads or fewer than 50 heads are seen. So the same process as you found out.
Yes.
So suppose a fair coin is tossed 200 times. So here, madam, like how do I fix my mu here?
Mu is NP, right? Mu is NP,
yes.
So it's 100.
So here I get the NP part. Okay, and my sigma would be.
So what is the variance of a binomial distribution?
Okay, got it.
Got it. Yeah. So the same way you can find. All right.
I told you, no, ma'am, the question actually I'm not able to take the screenshot. So can I tell you the question, ma'am, please?
Okay, you can tell me here.
5 unbiased coins are rolled independently.
Okay.
1 second. Let X be the sum of outcomes of all the dice. Find a lower bound on P mod X minus 17.5.
Mod
X minus 17.5.
X minus 17.5.
Less than or equal to 2 root of 175 by 12. Whole root, ma'am, it is 175 by 12.
Okay.
Using Chebyshev's inequality, enter the answer correct to 2 decimal places, ma'am.
So what is the bound here, right?
Yes, ma'am. It's a lower bound. Find a lower bound on.
Yeah, find a lower bound.
Yes, ma'am.
So, okay. What is 7? You had 5 fair coins. Correct. And you had to find the sum of the outcomes, you said. Can you repeat?
Yes, ma'am. 1 second.
Just the first sentence. Yeah.
Random variable X is the sum of the values by adding up the values on the 5.
Is it a coin? Or
unbiased dice, ma'am.
Dice, right? Yeah, that's what I got confused.
Are rolled independently. Let X with sum
so
of.
It's the same thing that somebody had just asked me about. So it was for the coins. Now here you have 5 dice thrown independently, and you have to find the probability that you have to find a bound on this probability, correct? Now, what is 17.5 that you will get here?
Mean and standard deviation is root 175 by 12.
Yeah, so this is your basically standard deviation.
Yes, ma'am.
And this is your mean.
Mu. Yes, ma'am.
Mean of, like, when 5 dice are thrown, this is your mean.
Yes, ma'am.
35 by 2.
Oh, 35 by 7. No, not 7.
35 by 2.
Yeah, 2. Yes, ma'am.
Yeah.
Ma'am, sorry, I didn't understand. How did that become the standard deviation?
Sorry, how did that become?
The standard deviation?
Ma'am, it should be K sigma, no, ma'am.
So K is what? K is 2.
Okay.
That should be 1 by 4.
So it should be 1 minus 1 upon k square. So 3 by 4.
Okay, ma'am. Thank you, ma'am. Yeah, I got it. I was confused. Actually, what I was doing was I was squaring it k sigma k into standard deviation. I was writing 2 root 175 by 12. And I was squaring it k square sigma square is equal to 4
Okay.
into 175 by
Okay,
12. There I was getting confused.
Yeah, so everything was already mentioned in the problem.
Ma'am, 1 minus 1 by 4, how is it? I mean,
Yeah,
it should be
so
1 by
1 minus
4.
1 by k square it is.
It
So
should
1
be
minus
1.
1 by 4.
So
it
you
is 3
have
by 4.
two inequalities that you have seen in the lecture 2 or 3. It's the same thing, different ways of writing it. So the first is probability that mod of x, I will not write x bar, this is x, minus mu greater than equal to k sigma. This is less than equal to 1 by k square. The second way we can write this as probability that x minus mu less than equal to k sigma is greater than equal to 1 minus 1 upon k square. The third way you can write this as probability that mod of x minus mu greater than equal to some constant c is less than equal to variance of x by c square. So everything is same, it's just a different way of writing.
Okay.
Yeah.
Thank you.
So you can use any one which you are more comfortable with.
Ma'am, but previously someone asked it is MP and mean is NP, that it will not function for this number. N is 5 and P is 1 by 6.
In this case, it will not. So we are interested in so you have 5 dice.
Hello, ma'am. Hello, ma'am.
Yes.
The second set of formula you are given.
This formula.
The second set, this one, the Chebyshev square. The second set, at the end it is not clear, ma'am. Greater than equal to, then what you written?
Okay, greater than equal to 1 minus.
Okay.
1 by k square. Yeah.
Okay, ma'am.
So we were at, so the random variable was defined as sum of the outcomes of the dice.
Ma'am, may I add something?
Yeah, please.
This mu is expectation of x, where x is some of individual and value that comes on individual dices. So we can break it into x1, x2, x3, x4, and x5.
Okay.
Can we do it like that?
I tried doing that. That is a very big method actually, because once after that you have to find the variance of x, which is expectation of x the square minus whole square minus expectation of x square. It's a very long process actually.
No, because x is IID. So for x1, x2, x3, all everything will be same. So it will be 5x1. So
5x1.
Yeah.
The number obtained on the first die plus number obtained on the second die plus third plus fourth plus 5. So if you find the expected value, this is just going to be 5 times expected value of x. So
and this value we have already 17.5.
This value is 17.5, is it? And total is 17.5.
Yes, total is 17.5 and expectation of x is 3.5. as we
Yes,
already know.
expectation is 3.5. Yeah. So it becomes 17.5, right? Yeah, thank you. So same way, you will find the standard deviation also. So you go by variance of x.
Yeah, ma'am.
So variance
Ma'am,
of
for standard deviation, we have to square those, this one, no, ma'am, that
no,
one square
like
is one.
variance of, now you are taking the random variable as this.
Yes, ma'am.
So if you find the variance of this, since these are all independent and IDs, you can write again this variance of x1 plus variance of x2. Again, it will be 5 times, and then use as like do square root.
Ma'am, it will be 5 square times, no?
Yeah,
Yeah,
5 square
A
times.
square, yeah. A
So
square
you'll
times.
just do square time, like do the square of
Yeah.
some variance of x. You will get under root 175 by 12.
And we have written as root. It won't be root. It will be to the power 5. No, 5 is square. Sorry, 5 is square, not 5.
A square times of variance of x. No, ma'am. Variance of ax is a square times of variance of x.
We are getting variance of x1 plus up to variance of x5.
Xn, x5.
So
Yeah.
this is 5 times variance of x.
Okay, ma'am.
Yes.
Ma'am, not 5 times. 5 is square times. Then that is 25 times where x, no?
Why we don't have variance of
ax
5x?
5 times
We
x.
have 5 times variance of x.
Oh, yes.
Yes.
Okay, ma'am.
Okay. So we have 2 more problems. Now the PDF of a random variable x is given to you. That is defined by k root x for x lying between 0 to 1. Otherwise, it is 0. So what should be the support of x? What should be the support of x?
Both option
Option
D.
D.
D for Delhi.
Yes, D. Yeah, right. Yeah.
Yes, ma'am.
So support of x, we define it as like all those value of x for which your fx of x is greater than 0. Right? This is how we define support of x. So so support of x we had discussed in last session also. No? We'll move to the second part. So
One question.
yeah.
So over here we have square bracket and round bracket. So I am hoping square bracket is showing it is going
Including.
Okay.
Including. So if I write open 0, 1, it means we are not including 0, 1, that point. If we are writing this closed bracket, right? So this 0 is inclusive. So this is the difference. Now we have to find the value of k so that your fx becomes a valid PDF. So we know that for a PDF to be valid, the integral of minus infinity to infinity, your fx of x should be equal to 1. Correct. Now, in this case, it is defined only for 0 to 1. Otherwise, it is defined as 0. So 0 to 1, k under root x, right? So you have k under root x dx. The formula for integral here is given to us. So in this case, your n is 1 by 2. So this becomes x to the power 2 by 1 by 2 plus 1, that is 3 by 2 divided by 3 by 2. And it varies from 0 to 1. So this becomes, so this should be equals to 1, correct? Now, this will become 1 to the power 3 by 2, that is 1. So this is basically 2 by 3. equals 1 by k. So k becomes 1.5. I hope this was clear.
Yeah.
So answer is 1.5. Now question number 3. We have find the probability that x is greater than equal to 0.4 given x is less than 0.8. Right? This means you have to find probability x is greater than equal to 0.4, comma x is 0.8 divided by probability x is greater than 0.8. Right? Sorry, this is less than equal to. Yeah. So this is 0 to 1 and x is less than 0.8. X is less than 0.8 and x is greater than equal to 0.4. So the common part is 0.4 to 0.8 here, right? So we will do the integration. We'll do the integration of fx of x. If you integrate the PDF, you will get the probabilities. So the lower limit will be 0.4 and the upper limit will be 0.8 divided by probability x less than 0.8. So the lower limit will start from 0 and the upper limit will be 0.8. So it will be fx of x dx from 0 to 0.8. Now, what is fx of x? It is k under root x, right? So k under root x and k we found to be 1.5. So 1.5 integral x to the power 1 by 2 dx 1.5. So basically this constant will get cancelled out. I can just write x to the power 1 by 2 integral dx from 0.4 to 0.8. Similarly, x to the power 1 by 2 dx from 0 to 0.8. Can you solve this? The integration formula is given. So this will become x to the power 3 by 2 divided by 3 by 2. And you take the limit. Similarly for the denominator.
0.65, ma'am, final answer.
Final answer will be 0.65. Okay. So these are very basic calculations. Yeah, very basic problems. So these you should know how to do all this. Okay. Like, but take this reason, like decide always. I will suggest draw a picture so that you can see you're not going wrong.
Ma'am, can you show the first part, ma'am? I didn't get the first part actually.
Yeah, this one.
The first part. No. First question, ma'am. Yeah.
Okay,
here.
first question.
Yeah, here.
Support. Support, you mean?
Yeah, this one, ma'am. Yeah, I didn't
Yeah.
understand actually. Yeah.
Okay, so what is support of a random variable? It is like support of any random variable is like it will take only such values of the random variable such that its PDF is greater than 0. This is the definition of support.
Okay.
Right.
Okay. All right. Okay.
Is it okay?
Ma'am, I have just one question.
Yeah.
In this definition of the PDF, had the bounds been less than equal to 1?
Has the bound
Had the bound been
okay
less than equal to 1, then would B be the right option?
Would be the right option. No, still it will be 0 to 1. Like open interval 0 to 1.
No,
because,
I'm asking 0 less than equal to x less than equal to 1.
Yeah, you're asking about this, correct?
Correct.
So still in this case also, since x is a continuous random variable, you're at point x equals 0 and x equal to 1. It will take the value 0. Probability will be 0. Right?
Okay.
So the support will be open 0 to 1.
Ma'am, in that case, support will always exclude the endpoints?
Yeah.
Yes.
Because at this particular point, at point 0 or point 1, the probability is going to be 0.
Got it, ma'am. Got it. Thank you.
Yeah. So everything is clear in this question.
It is clear. The last important.
The last one.
Yeah, the important. No, the last one. Now next question. Next question.
Okay, next question. Okay.
Yes.
Sure.
This is.
So this problem says you have 10 random variables, and all these random variables are IID Bernoulli 1/4. Okay. You have defined another random variable y as y equals x1 plus x2 up to x10. Okay. So we know that the sum of independent Bernoulli will give you binomial. So I hope the first part should be clear. Which of the following option are true? So what is going to be the answer for first question here? First part.
E and C.
B and
A and C.
A and C.
A and C, ma'am.
C.
Yes.
Yes, because each of the samples here, each of the x1, x2, x10, they are all Bernoulli and they are all independent. So the sum of independent Bernoulli will give you the binomial distribution. So total number of successes in 10 trials basically. And the probability of success in each trial is going to be same. So it models a binomial distribution with parameter n equal 10 and p equals 1/4. And if you have a binomial distribution, the range of values that it can take is from 0 to n. So in this case, it is n equals 10. So the range will be from 0, 1, 2 up to 10.
Ma'am,
yeah.
Can you explain me regarding the probability how it can it become 1/4?
How the probability becomes
1/4 for this question.
14th question.
No, for this question, question
Okay,
number
okay.
10.
Okay, why p is 1/4? This is what you're asking, right?
Given question.
Second part or the first part?
Part, ma'am. First part.
First part. You are asking about why p is 1/4.
It is 10. I understood. But 1/4.
Okay.
How?
So you have 10 samples here: x1, x2, up to x10. Okay, and these all are IID Bernoulli 1/4. So if we say they all are IID Bernoulli 1/4, it means this x1 is Bernoulli 1/4, x2 is Bernoulli 1/4. So each of x1 will take 0, 1, x2 will take 0, 1. Similarly, x10 will be 0, 1. Where the probability of success, it means probability of 1 is 1/4, probability is 1/1, 1 is 1/4, and so on, right? This is what we mean.
Yes.
And they all are independent. x1, x2, x10, all are independent. Now, if we add these random variable x1 plus x2 plus x10, if we add this, so what does it give basically? So we know each of xi can either take the value 0 or can take the value 1. x1 can take the value 0, 1, x2 can take the value either 0 or 1. Similarly, x10 can take either the value 0 or 1. So if you sum the whole thing, x1 to x10, what should it give?
Either 0 or 10.
No. So let's say if x1 is taking the value 1, x2 is taking the value 0, let's say x3 is taking the value 1, x4 is taking, let's say, value 1, x10, let's say, take the value 0. So if I sum everything, let's say we had just 5 random variable. If we sum it all, so what value does it give? 3, right?
Yes.
So out of 5 successes, you have 3 successes. The total number of successes that you get in 5 trials. If we had 5 random variables. Okay. This is what we mean. So this kind of situation, like number of successes in n trials. So such models the binomial distribution, right? So this sum will model the binomial distribution, and we know the binomial distribution has two parameters. One is n and other is p. So what is n? N is total number of trial. So total number of trial in this case is 10. You have 10 independent Bernoulli trials. So you have 10 trials, so you'll write 10. And the P is probability of success in each of the trial. So what is probability of success in each of the trial here?
1 by 4.
1 by 4, right? So this is how we get 1 by 4. This is nothing but probability of success in each of the trial. And each of the trial is like first, second, third to 10.
Okay. Thank you, ma'am.
Yeah.
Also the range part, shouldn't it be 0 to 9?
Why it should be 0 to 9? Like if I have binomial, okay, let's write it here. If I have binomial n comma p, okay, so you have n number of trials. So how many successes are possible? Number of successes in n trials. What are the possibilities? You have n trial. How many successes can you get in n trial?
You can get success in each and every trial. And trial.
Yeah, so number of successes in n trial that you can get is either everything is failure, or you can get just one success, or you can get two success, you can get three success, and maximum it can go is to n success. So the range is from 0 to 10.
Thank you, ma'am.
Yeah. Now coming to the second part of this question, it says find the value of probability that x equal 1 given y equal 8. So probability y equal, so x1 equals 0 given y equal 8. So first of all, we will write this in the form of joint divided by marginal. So this is going to be probability x1 equals 0 comma y equals 8 divided by probability y equal 8, right? And this is nothing but probability x1 0 and y is defined as x1 plus x2 plus up to x10 equal 8 divided by probability y equal 8. Once you substitute x1 equals 0 on this side, or what you can do is you can write this joint distribution as probability y equal 8 given x1 equals 0 times probability x1 equals 0 divided by probability y equal 8. For some time, we'll just leave this part probability y equals 8 because we know that this y models the binomial distribution with n equal 10 and p equal 1 by 4. And we can easily find this probability. So for now, we can just leave this part. This numerator part, is it clear? Like why did we write it like this?
I have a doubt in that, ma'am. I'm not able to understand that numerator part.
Okay, so this is just, yeah, just one way of writing it. Like you're writing the joint as joint conditional times marginal. So what will happen is, like once you write it in this form, so given x1 equal to 0, so once you substitute x1 equals 0 here, it becomes probability that x2 plus x3 plus up to x10 equal 8 times probability x1 equals 0. It means it is the first random variable is a failure divided by probability y equal 8.
Ma'am, in this case, we are assuming that in the first one only failure, but it can be any other case also.
What?
The failure x1 equals to 0, we have assumed. in any other case, it can be also x2 equal to 0 or x3 equal to failure can be any other case also out of 10 cases.
Yeah, means x1 equal to 0, x2 equals 0, everything means the same thing. I mean, they are just 0 means a failure and 1 means success.
Okay, means it's just a interpretation of writing this format in other way.
I think I didn't get what you're trying to say.
It's you are just trying to interpret the same means this expression in with change means probability of x1 equal to 0 and y given y equal to 8. So you are just writing in other way.
Yes, this I mean the second step you're talking about.
Yes.
Yeah. Because once you do this, like given x1 equals 0, you can write this as like you can just substitute x1 to be 0 here, and this y equals 8 becomes x2 plus x3 plus up to x10 equals 8. Right. Now for this we know, this probability also we know. But what about this probability? So what about this probability? Anyone?
One minus.
1 minus, yeah.
Probability of x1
equal to
0. 1 minus probability of x1 equal to 0, ma'am.
You are saying this is 1 minus probability that x1 equals 0.
Yes, ma'am.
There is one more x which is
Okay.
0 because it is.
Why is it this? Why is it this?
What now?
Why did
Directly
you
one-
write? So you
Ma'am,
have
it
said
should be like x2 or x3 or x4 or x5. One of them should be 0. Out of x2 to x10, one of them should be 0.
Yes, there is one more 0.
yeah.
So
Please tell. Yeah.
we can write it as px2 is 0 or px3 is 0 or px4 is 0. So we can break it up.
Okay, so it will be a little complicated if you do this. There will be many.
Ma'am,
Yeah.
I've taken a different approach to this.
Yeah,
I'm not sure if it is right.
Okay.
What I've simply done is if you scroll up a bit.
Okay.
Further up.
Okay.
So what I've done is in this case, y equals to 8. So probability of y equals to 8 is 10 choose 8. So 45 possibilities. And when we have 10 choose 8, so that is 45. And x equals to 0, given y equals 8. So in that case, if x1 is 0 for sure always, another variable which has to be 0 since y is 8 can either be x2 or x3 or x4. So in this pair, combination of pairs, there are 9 possibilities. So simply 9 upon 45, which gives 1 by 5, which is nothing but 0.2.
Okay, I will just write it down what you have just told. So probability y
equals to 8.
Y equals 8 given x1 equals
No,
0.
ma'am.
No.
No. Just y equals to 8.
Okay.
Is 10 choose 8.
Yeah, right. 10 choose 8.
That's 45. That is equal to 45 for
You are
possibilities.
finding probability.
Yes, ma'am. But that is if I take the entire sum in totality, in terms of probabilities, not.
Okay, so you are just saying okay.
It's
You're
not
just
the probability
choosing
actually.
8.
Just
Yeah, it's not
y
probability.
equals to 8, not probability. Just y equals to
It's
8.
way of choosing.
Yes.
8 random variables. That is
Yes.
10 choose 8.
That's 45.
Yeah. Okay.
And if y is 8, given y is 8,
Okay.
and x1 is 0, if y is 8, it means there are 2 failures and 8 successes. So if x1 is always 0,
yeah,
then either x2 has to be 0, x1
x3.
is 0, x2 is 0, or another pair is x1 is 0, x3 is 0. So such type of 9 pairs possibility is there.
Yes.
So basically 9 by 45 can also give us the same answer.
Yes, I think it's a much easier way. Yeah, right.
It is 10C8, 1 minus 1 by 4 power of 8.
No, we are not. Yeah, we are not trying to find the probability here. So it was just how many ways you can select 8 random variables out of these 10 random variables. So what she has done is, so we had to find probability x1 equals 0 given y equals 8. So given y equals 8, it means the sum of the random variables should be 8, right? So this can happen if you choose any 8 random variables out of those 10 random variables. So you can select any such 8 random variables and 10 choose 8 ways. So this gives you 45. So you have 45 ways to select these 8 random variables. Now, given you have sum of 8 random variables to be sum of 10 random variables to be 8, what is the probability that x1 equals 0? Right? So if you look at the numerator part, right? So number of ways this x1 equal to 0 comma y equals to 8 happens is
9.
x1 0 is fixed. Yeah. So x1 0 is fixed. So it can happen in just 9 ways. So either the sum will be 8 only if, let's say, x1 equals 0, or it can be x2 equals 0. Then it can be either x1 equals 0 or x3 equals 0, or it can be x1 equals 0 or x4 equals 0. So once you do this, you will see that there are only 9 such possibilities, right? So total number of ways in this in which this can happen, the numerator part, that x1 is 0 and the sum is 8, it can happen in just 9 ways. And number of ways in which the sum can be 8, that can happen in 10 choose 8 ways. So this just become 9 upon 45, and this is 1 upon 5, which give you 0.2. Yeah.
So this is the probability of y equal to x given x1 equal to 0, right?
So basically the common like number of ways in which this can happen,
Yes,
number of ways in which this can happen. Yeah. So number of ways in which you can choose 8 random variables out of 10, and number of ways in which this can happen. It means one random variable x1 is fixed and the sum should be 8. So that can happen in only 9 different ways. So we are just doing it 9 by 45. So this was one way to do it. The other way that we were doing is this part. We are writing it using the conditional time marginal. So there we had to do probability x2 plus x3 plus up to x10 equal 8. So how do you find this probability? How do you find this probability? Anyone?
It's
Yeah.
summing up all the middle x2 3.
What? Can you tell again?
Ma'am, I'm thinking like in N choose k 1 minus p power k into p.
N choose k 1 minus p to the power k into p. So what is n here?
N is 9.
N is 9. What is k here?
K is 8 number.
Right. And p is?
P is 1 by 4.
Yes. Yeah, this is right. So, yeah, can you tell me like why did we write it like this? If you can explain.
That we are getting failure up to 3 by 4 times and we got success in one time, 9th time.
So basically this expression here, like x2 plus x3.
There are 8 successes now.
Yeah, you have sum of 9 random variables here, where these random variables has models the binomial distribution with number of trials equal 9 and probability is same 1 by 4. And what number of successes that happens is 8. So that is why we are taking n to be 9, k to be 8, and p to be 1 by 4. So once you find this, we know this probability y equal 8. We know this probability, and x1 equal to 0 we also know. So you can just calculate this and you will get 0.2 as the final answer. Yeah.
Ma'am, can you please explain this one more time?
I think it will be 9 choose 8.
Yeah.
1 upon 4 to the power 8, because 8 successes are there, and then 1 minus p, one failure is there, so 3 upon 4. 9 choose 8 into 1 upon 4 to the power
Okay,
8.
yeah, right. N choose k, p to the power k.
Yes, sir.
Yeah. N choose k, p to the power k. 1 minus p to the power n minus k.
Yes, sir. Now it will
So
be
9 choose k, p to the power k. So p is 1 by 4.
To the power 8.
And 3 by 4 to the power 1.
Yes.
Yeah.
Yes, ma'am.
So can you solve this now?
And probability of x1 is 0, ma'am. It is 10 choose 0, 1 by 4 is to 0, no, ma'am.
Sorry?
Into that is p of x2 plus x3 so on up to 8, right? Into p of x1 is equal to 0, right?
Yeah. Right.
That is 10 choose 0, no, ma'am.
Why 10? You know, x1 is a Bernoulli random variable with the parameter 1 by 4. So this is just nothing but 3 by 4.
Okay, ma'am.
Okay.
So again, 1 3 by 4 will come.
Yeah.
Ma'am, I have a question in practice assignment. Could you please help me?
Practice assignment.
Yes, just solution. I do have seen the solution. But
Okay,
only
so before that, is there any doubt? Everything clear in this?
This question is clear, ma'am.
Okay.
But this question actually opens the door for many other questions. Actually, what I want to say in lecture number
We are getting answer point not 2, not 0.2. It's point not.
Is a calculation error.
Scroll up little bit.
Okay.
Even more than.
Okay. Anything?
Yes, ma'am. I was saying.
Ma'am, will you be upload this document?
Yeah, I will be uploading this PDF file. So if something is not written clearly, I will write it down.
Could you please mute my some type?
Ma'am, like
Okay.
ma'am, till what time? Like, will you be upload by today?
So by I will send it today, but maybe it will get updated by tomorrow morning.
Ma'am, I was saying something, ma'am.
I have one silly question.
Okay.
When we say FZ, what do we mean by FZ inverse?
When you say FC.
Okay.
Ma'am, can you please just once
yeah, please go one by one. Shaval, can you tell me?
Yes, ma'am.
Can you stop for some time? Shaval, can you please tell me?
Yes, ma'am. Ma'am, what do we mean by FZ inverse?
Okay, you want to know what is mean by FC inverse?
Yes, ma'am.
Okay, Z we know that it is normal 0, 1. Right? Normal with mean mu and variance 0, 1. Now, let's say we have written probability Z less than equal to Z. Let's say this comes out to be C. Okay, this is nothing but Fz of Z. This is C. So Z, the small z, will become Fc inverse of C. Right? If you plot the graph of the normal standard normal distribution, then center will be at mean, that is 0. And we are saying for any small z, let's say this small z is here. For this set, probability that z is less than equal to this small z is C. So we are saying this probability is C. Okay. And this is same as Fc of Z. Now this Z is, we are saying this Z is nothing but Fc inverse of C. Okay. So let's say this probability, this C, right? This C is going to be a probability. Let's say this probability comes out to be 0.95. So there should be some point on your this line. There should be some z, some small z, for which your probability comes out to be 95%, 0.95. So the point at which this probability comes out to be C, it means 0.95. That point is Fc inverse. This is what Fc inverse gives, this point.
So ma'am, how do we calculate that if we ever get a question saying calculate
Yeah,
FC?
okay. So if I'm saying FC of 1.64, I think this is right. So this is true. Okay, let's assume this is true. Okay, so this is a small z, right? So this 1.64, this is the small z, becomes Fc inverse of 0.95. So this will be given to you in the problem. This will be given to you that this is true. Okay. Like if you look at the problem statement, these hints will always be given. So this is nothing but your small z. And this is your probability. So z is 1.64. So if I'm saying this is 0.95, I will say at 1.64, your CDF is coming out to be 0.95.
Okay, got it, ma'am. So we can always say that Fc inverse of the given probability would be the point, which is the Fc point.
Yeah.
Okay, got it, ma'am. Thank you so much.
Yeah.
Thank you.
Ma'am, then how do you calculate that Fg inverse 0.95? Like, how do you calculate it?
Fc inverse of 0.9, you don't have to calculate it. This is nothing but 1.64. Like these values are already given, calculated in the table.
So
These values are already there.
So
you don't have to do anything.
Ma'am, we will be subtracting then that 1 minus 0.95, or will you no need to subtract the values?
Why do you want to subtract it?
So like we will just mention that Fz inverse 0.95 is equal to that value.
1.64.
Yeah. Ma'am, shall I ask now or shall I wait for some time?
Ma'am, I have a problem with the previous question.
Okay, let's go to the previous question, and yeah, what all dots is there? Just let me know.
Ma'am, just didn't get that probability y equal to 8 in the denominator part.
Y equal 8 in the denominator part. So you know that y models the binomial 10, 1 by 4. So can you find y equal 8? Probability y equal 8. We know that y is binomial 10, 1 by 4. So what is the probability that y equal 8? What is the probability?
Okay, that would be, I guess, be 10 choose 8, then 1 by 4 to the power 8, and then 3 by 4 square.
Yes.
Okay, thank you.
Right. Anything else from this problem?
Yes, ma'am. I was saying something, ma'am.
Okay, tell me.
Yes, ma'am. This problem is clear, ma'am.
Okay.
But related to this only, like in the lecture 2.10, at the end, professor has given couple of exercise, like to find out the sum of
Yeah, right.
independent geometric
Yeah.
and geometric, and then
Yeah. So
IID
did you try? Did you try that?
I tried, ma'am, but could not resolve all, could not solve all the exercises. So the point is that
Okay.
if that kind of question we come across in the quiz, then there will be some problem, ma'am. So how to address that?
You just need to know the result, final result. I will say. I won't say you should know how to
Yeah,
derive.
because
Just the result, if you know, it is
final
enough.
result is not discussed, ma'am, in lecture also. So
Okay, so you can also search on discourse. The final results are already somebody has already answered it. Not in this term, the previous term, if you look at it, right? So you just go and check on discourse. It is there. So for all the 5 exercises that sir had given, so what the distribution will follow, all this is there.
like similarly for Poisson, he had shown that if we add 2 Poisson, then the outcome is also Poisson distribution.
Yes.
And if we take conditional, then they become binomial.
Binomial, yeah.
So if related question comes in quiz, like in case of Poisson,
you will have to remember it. The result you will have to remember. The results are important. How the derivation comes, yeah. Result you will have to remember.
Because one part is summation, the other part is a conditional also. So if
Yeah. So whatever sir has done, the result, right? In the lectures, whatever results are done by sir, you should know this.
So at least you should be thorough with that.
Yeah, you should know the results. Yeah.
How similar our question paper will be like to our mock questions, or it will be tougher than our
almost same, I would say. Not tough, I guess.
Any tip, ma'am, for the quiz, ma'am?
Any tip for the quiz? Just whatever problem you're solving, just know the concept properly. Like basic things you should know. There are not any tips I can give. It just you should practice a little.
Ma'am,
So you can.
Ma'am, in previous some previous questions, we saw like questions coming about the weak law of large numbers and central limit theorem.
So those are not taught yet in your course, so don't worry about that. The portion will be from week 1 to 4.
Ma'am, one small doubt here. Like these distributions, no, how will we easily remember? Okay, this problem will follow geometric or like Poisson's distribution or like that. Is there any easy way to remember any technique, ma'am? Because unless the question specifies, it is difficult. Can you please, yeah.
Explain like what how to decide which distribution does it follow.
Yes, ma'am. Yes, ma'am.
So I will suggest like you saw the practice book.
Ma'am, practice wala problems I saw everything, but actually easy way to remember. Like I was just thinking, is there any other way we can remember or something? Because I'm the moment I see, I get like again I need to open the thing and just refer. I thought if any easy way so that we can remember, we can implement easily.
Okay, so the first week lecture live session, I had explained all the distributions. Yeah, maybe just that live session you can just check once. I think it was the first live session. First or second, if I'm not wrong. So all the distribution were covered there. You can just go and have a look. Okay.
And the live session video is on our on the website.
Not on the website. It will be on the YouTube.
Link is given in calendar. All the links are given in calendar.
Okay.
Okay, ma'am. Ma'am, actually, I have the solution like practice session assignment solution already uploaded. Just I need to understand from you like how that steps are followed. Maybe quickly we can
Okay,
guide
just
me
let
that.
me stop sharing this.
Will you please? No,
We'll
ma'am,
close.
practice
This is the last doubt we are taking. So
yes, ma'am.
yeah.
Ma'am, this will be week 3, question number 5 and 7.
Week 3, question number 5 and 7. Okay.
Ma'am, if you can open the PDF, yes.
So others, you can drop off the session. Just the last problem that we are taking here. Three, is it?
No, ma'am, 5. Question number 5.
Okay. 5 we just discussed. I mean, the mock we had the same type of question.
Actually here, ma'am, here that
It is same. It is exactly
this
same.
40,000 where I got this 40,000 and 40,000 minus 40,000. Is it
Yeah.
that 60 minus
Okay.
20 I did and got the 40,000?
I would suggest, like we just discussed this problem in the mock. So similar kind of problem. I would suggest just go back and say it once. Okay. This is exactly same what we had just discussed.
Just only this 40,000 it came from 60 minus 20, like that only we get. Mu
So
minus sigma.
this is mu plus k sigma, not mu minus sigma. Mu plus k sigma and mu minus k sigma.
And k value, ma'am, here is not given. K value we will find out.
Please just have a look over the mock. Just we have today only we are discussed. Just please check similar problem, exactly similar.
2 sigma plus 2 sigma minus 2 sigma.
And ma'am, one more problem, 7, yes, this one also, ma'am. Here, how did you expand this formula? Like covariance of 2x x plus this line, can you explain this line only?
The first line.
First
line, right?
Second line.
Second line.
First line understood.
So the first step is covariance of 2x comma x plus x y square x plus covariance of y comma x plus y square x, right? Now it is the property of covariance that if you have two random variables here, let's say x comma y plus z, then it becomes x comma y plus x covariance of x comma z. Same thing we have done it here. So it becomes covariance of 2x comma x plus covariance of 2x comma y square x. It's just the property of covariance. Similarly, the second term we have here is covariance of y comma x plus same thing we did here. Now the third step, if you come, so covariance of, it is the property that covariance of x comma y becomes a times covariance of x comma y. So here it becomes covariance of 2x comma x becomes 2 times covariance of x comma x, right? The second term, covariance of 2x comma y square x becomes 2 times covariance of x comma y square x, correct? Third term is same and fourth term is same. Now covariance of x, we know it is variance of x. So this becomes 2 times variance of x. Then similarly, the second term, this covariance of x comma y square x. So this alone, we have used the formula of covariance, correct? So covariance of x comma y is given as expectation of xy minus expectation of x times expectation of y. So in this case, our first random variable is x and the second random variable is y square x. So we have written it as expectation of x square, x square y square. Yeah.
Ma'am, actually, for a minute I got disconnected. The third line you're explaining, can you please repeat that one, please?
Okay, so covariance of 2x comma x, covariance of x comma x becomes a times covariance of x comma x. It is a property of a covariance that covariance of x comma y becomes a times covariance of x comma y, right? The same thing we have done in the third step. So 2 times covariance of x comma x, 2 times covariance of x comma y square x, and the other two terms are same.
Okay.
Right?
Yes. Ma'am, then fourth line actually covariance, the OXX becomes variance of x plus twice of E of x square y square minus ex. That one
Fourth is
again
clear?
the property of
Oh, it
fourth
is just the
line, fourth
definition of covariance. If you have two random variable x comma y, covariance of x comma y becomes expected value of xy minus expected value of x times expected value of y. In this case, the first random variable is x, the second random variable is y square x. So this becomes expected value of x square times y square, right? X into y square x. So x square y square minus expected value of x times expected value of y square x. Correct?
Yes.
So we have just used the formula.
Last one, the covariance of x twice of covariance of x comma x, that is only variance of x, right?
Yes. Everything is just the property and definition. We have used nothing else.
Okay, I got confused here, ma'am. That covariance of x become only variance of x. That is only one. Thank you, ma'am.
Okay. Yeah, thank you. Yeah. So I will upload this mock, what we just discussed, the same PDF. Maybe just something we will change. And if some answers are not written properly, I will write it again and upload it on the portal. So maybe not, if not tonight, maybe by tomorrow morning, it should be updated. Okay.
What is the plan for tomorrow, ma'am?
Sorry?
What is the plan for tomorrow?
Plan for tomorrow. So tomorrow you will be revising from week 1 to 4.
From week 4?
No, you will be revising the topics for quiz 1.
Okay. We'll have live session tomorrow as well
Yeah.
on the same link.
The link, you can find it on the calendar.
Yeah. Different link, but at the same time.
How can I find that on calendar? Because I'm not getting anything on my calendar. So can someone help
Maybe
me with
you
that?
will have to add your calendar, the calendar to your email ID.
Can someone give me the link? So that I can...
You can go to the portal. So in the portal about the course, you will find the calendar. So just add that calendar to your ID.
Okay, we'll do that. Thank you.
Hello.
Yeah.
Ma'am, in sometimes like one question which I had seen regarding conditional probability is they're asking about given xy are two independent geometric 1/4, find the probability that x equal to 10 given minimum xy equal to 5 or 6 or 7, something like that.
Okay. These are previous CA questions, right?
Yes, ma'am. I kind of like found it out. So like minimum, ma'am, how to go about that?
The solution, maybe you can find the solution also for that. Just think about it, about that question.
Okay, ma'am.
Yeah, it's already 9:22 now.
Was
or if it is not very clear, you can put it on discourse also.
Okay, ma'am.
Okay, yeah. And also we had said that you can try for finding the expected value of geometric distribution. Why is it 1 by p? So if somebody wants to like share the answer, you can put it on discourse. Okay. Okay, so that's all for today's session.
Thank you, ma'am.
Thank you all for joining the session.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am, and good night.
Yeah,
Thank you,
good
ma'am.
night.
Thank you.
Thank you, ma'am.